રાગભાઈ હેલો.
હા સાહેબ.
આ જરા ખોટું એન્ટર થઈ ગયું છે, મારે બીજું કરવાનું હતું.
અચ્છા, આ તો
હે
સર પીપીટી ક્લોઝ કરી દો ને. સર તમારું પીપીટી ક્લોઝ કરી દો ને તમારું જે ઓરિજિનલ મતલબ જે તમારે દેવાનું હોય ને એ પીપીટી ખોલી નાખો, વાંધો નહીં.
ઓકે ઓકે ઓકે.
સ્ટોપ શેરિંગ ને સ્ટોપ શેરિંગ ખાલી પીપીટી જેમ બંધ કરી તમારે જે પીપીટી હોય ને ચાલુ કરી દો. સ્ટોપ શેરિંગ
લાઈવ ના કરતા.
હવે આ ઝૂમ ને કેવી રીતે કરવાનું છે? પાછી જોઈન કરવાનું?
નહીં,
સ્ક્રીન શેર કરો.
સ્ક્રીન શેર કરો. નીચે સ્ક્રીન શેર કરશો એટલે ઓટોમેટિક બધું આવશે. શેર સ્ક્રીન.
હા હા, એક જ મિનિટ. પણ મિનિમાઇઝ થઈ ગઈ છે ને?
ના ના, અમને દેખાય છે તમારો કેમેરો. હા, પાવરપોઈન્ટ મિનિમાઇઝ નહીં કરવાનું છે, એને ખુલ્લો જ રાખો.
ખુલ્લું જ રાખો.
હે?
એ તમારું ખુલ્લું ઓપન જ રાખો.
પણ અહીંયા નથી થતું ને મારામાં શેરિંગ.
શેર સ્ક્રીન ડોટ
શેર સ્ક્રીન કરાવો પછી પીપીટી ઓપન. સર પહેલા શેર સ્ક્રીન કરી નાખો પછી પીપીટી ઓપન કરો સર. પહેલા ઝૂમ માં જે ઝૂમ ને મેક્સિમાઇઝ કરો પછી એમાં શેર સ્ક્રીન કરી નાખો.
બરાબર છે, પણ મારામાં આમાંથી જતું રહ્યું છે ને.
મિનિમાઇઝ
મીટિંગ આવે છે.
ના
લીવ કરી દો, ફરીથી જોઈન થાવ.
ના, ઝૂમ સર છે, ઝૂમ માં
ચાલુ જ છો
કનેક્ટેડ છો.
ચાલુ કેમ કરે?
કનેક્ટેડ જ છો.
અહીંથી મોટી કર. હા, તે હવે બરાબર. હવે શેર કરી લો. કરી દે. આવી ગયો?
હા સર.
હા,
હા સર.
આ પાછું જૂનું આવી ગયું ભાઈ.
હા,
તો સર ઓનલી પીપીટી તમારું ક્લોઝ કરીને જે પીપીટી હોય ને એ તમે ઓપન કરી નાખો.
પીપીટી જ ખાલી બંધ કરી દો.
પીપીટી જ બંધ કરી દો, ઝૂમ બંધ ન કરતા.
ટીમ સિસ્ટમ તો છે સાહેબ.
ઇંગ્લિશ
હવે
નવી પીપીટી છે.
હા,
ક્યાં છે પીપીટી? એ ખોલી દો. પણ એ તમારામાં ખુલ્લી
જૂનું
છે.
જ છે પાછું. क्यों करना है तुम्हें तो? सवाल आया था। हाँ, तो वो बंद कर दो। એક જ છે ને?
તમારે ફરીથી શેર કરવું પડશે. તમારે તમે હોસ્ટ છો, તમારે અહીંથી બધાને ઇન કરો.
હા, ઓકે કરી દો.
આ શેરિંગ નથી. आ क्लोज कर दो पहले, हाँ मिनिमाइज कर दो, क्लोज कर दो यार। शेयर स्क्रीन।
Sharing my to this.
અહીંયા એડમિટ કરી દો બધાને.
I am black. Ready?
Okay, sir.
Good morning to all. Dear participant, today we are with Professor R.B. Maravia sir. He is working as Executive Director Agriculture in Sardar Sarovar Narmada Nigam, Gandhinagar. In fact, he was working in Junagadh Agriculture University before 15 years. Then after the demand of government of Gujarat, he has been placed at Sardar Sarovar Narmada Nigam on deputation. Let me introduce. Let me give brief about him. He has earned Bachelor of Engineering in Agriculture from the NAHEP-IDP Udaipur. He obtained Master of Engineering in Agriculture from NAHEP-IDP Udaipur in 1988. He also got post-graduation diploma in Management of Agriculture Extension in 2007. He is having total experience of 40 years, more than 40 years. Now, presently, he is doing the planning and implementation of command area development activity for the sustainable irrigated agriculture, including monitoring for environment safeguard measures. His duty is evolving policies, perspective planning and coordination of the activity of land resources conservation, development and management. He is also guiding MTech, BTech and PhD project. He is also having 13 postgraduate dissertation in his credit, 10 undergraduate, and total he wrote 80 papers. Other publication, books, manual, proceeding and reports, he is having 15 numbers. Extension and popular article 79. He delivered radio talks, TV talk program totaling 28 numbers from All India Radio and Doordarshan. And he delivered the special lectures, more than 83. So this is about him. I think now I request Maria sir to start his presentation.
Good morning, sir. Good morning. So first of all, I would like to congratulate all the participants for selecting such an topic which is need of the time. Before I start about the detail about pins and MIS, commonly we call it as a pins plus MIS in our popularly, because first if we create pins, network of pipes, then we can join, we can establish or we can develop the micro irrigation system also up to the field level. So pins plus MIS is the topic for today's discussion. Now, before I start, because whatever I am going to make you aware about is on the Sardar Sarovar project, and to know about the Sardar Sarovar project is a basis. So I would like to brief you about the project first. This is a project which is having cultivable command area 18.46 lakh hectare. I think this is the biggest in the state and the country, which also cover 300, which covers about over 3,000 villages of 77 talukas and 17 districts of Gujarat. So almost a very large area of the state is covered under the command area. Also, I would bring under your information that the most of the area covered is arid and semi-arid, or over 2/3. More feature which is relevant to bring to discuss is the problematic area, so-called Bhal area, Bharatrek area, saline area of Surendranagar and Patan district, all are in the command area. So this is a crucial command where the management is very important. If we think about the canal network, the total length of the canal is over 70,000 kilometers, comprised of main canal 458 kilometers. The rear 70 kilometers is in the state of Rajasthan, because Rajasthan is also getting water through this project. Branch canals, there are 38 branch canals comprised of the length of 2,731 kilometers and about 727 distributaries and over 4,500 minors. Now, since this area is very problematic and arid and semi-arid, having wide variability of agroclimatic conditions, the government of Gujarat appointed a group, so-called Narmada Planning Group, comprised of very eminent personalities of the country. Okay. Sometimes for few years headed by Dr. Y.K. Alag, our ex-minister of central government. And the planning group has worked for years, gave so many studies covering various aspects of the water management and project outsourcing of the studies involving world level expertise were carried out. And based on all these efforts, the planning group has classified the command area into 13 agroclimatic regions. The basis for classification were topography and landforms, groundwater features, drainage pattern, rainfall, land irrigability classification, class, and canal alignments. Now, land irrigability classification, again, land is classified as per the irrigability capability, which is derived parameters, and we are presently monitoring the entire command area for the variables like groundwater depth and quality, pesticide residue, soil quality, and somewhere where the problematic area exists, where we observe all these at every 30 centimeter depth of soil strata by deep agar bore also. So after the having collection of this data, the area is classified into land irrigability classification classes, and more than half of the area is having less suitable for sustainable irrigated agriculture. And for that, because of that only, very precisely and very carefully, irrigation is being practiced at present. Now, water allowances is allotted to the command area is different. All different for all these agroclimatic regions. So it is a crucial thing that the delivery of the water is to be made in a different quantity in different agroclimatic regions as per their eligibility of irrigating practices. One more thing is, this project is providing drinking water for over 9,500 villages and 173 towns of the Gujarat. If we look to the water allocation, the water resources available for the project as estimated at 75% dependability is 28 million acre feet, which is distributed among four states rather. Madhya Pradesh is having the biggest state share, that is 18.25 million acre feet, Gujarat 9 million acre feet, Rajasthan 0.5 million acre feet, and Maharashtra 0.25 million acre feet. So when we look for the Gujarat and this command area irrigation, the 9 million acre feet again is planned to augment by more 3 million acre feet by resource creation in the in-route rivers, from the in-route rivers and on farm. And ultimately, this 12 million acre feet available to Gujarat is distributed or is provided for irrigating 18.46 lakh culturable command area. And after having deduction of the losses or the consideration of efficiency, the water reaches to the field is about 33 centimeter. With this quantity of 33 centimeter, it is intended to provide life-saving irrigation during Kharif season and the irrigation for Rabi season. So when we see the quantity, normally in the command areas, water being utilized by the farmer is over 1 meter. And in the case of Sardar Sarovar project, the available water is only 33 centimeter at field level. And therefore, it is a must to adopt micro irrigation system in this command area. Now, we have to consider a crucial factor of groundwater also. This is the project command area is not only having qualitative problem of soil, but there is groundwater quality is also inferior. The graph shown the different agroclimatic regions, all the 13s, and it is having the quality of water, quality rating. So good quality water is in the two agroclimatic zone only, that is Sankheda and Sauli, Sinor and Vadodara, that is on the upstream or the upper side of the command area. And as we come on downward sides, in the Kutch, Samihari, Radhanpur, Rapar, and in some area of Dhodka and Dhanduka, and Bhagra and Jambusar. Bhagra and Jambusar, that is a Baratrek area, and Dhanduka and Dhodka is a Bhal area. All are having very inferior quality of groundwater. Now, the water distribution plan of the command area plan indicates the 7 days on-off of the canal, that is specifically minor, and it is planned that the water will be supplied to water user association who looks after a village service area comprised of 200 to 500 hectares. So each village is having separate minor, more or less, and an organization of farmers called Water User Association. They have to take care for distribution and all management of water below the minor. That means from minor head to the field. VSA is comprised of 4 to 10 chucks of area of 40 to 60 hectares, which is further subdivided into sub-chucks up to 5 to 8 hectares. And you would be happy to know that the entire network up to the minor is concrete line, and from minor to sub-minor up to 5 to 8 hectare is underground pipeline. So all the efforts for minimization of the conveyance losses is made so far. Now about 1 lakh, over 1 lakh hectare is remain. The remaining area is already developed. Now mode of internal distribution is planned on rotational water supply basis, ensuring equitable distribution as per the area holding of the farmers. And this is to be done by the individual water user association as per the plan. Now, generally we know we have the very wide gap in almost all command areas of the country between potential created and utilization, actual utilization. And for that purpose, to minimize this micro level infrastructure development and efficient farm water management practices are the need, are the essential. And optimization of agricultural productivity and production is the other aspect for bridging this gap, besides improvement in socio-economic condition of the farmers. So this is our purpose or aim or objective, we can say, for better irrigation practices. Now the thrust area to achieve this one is beneficiaries' participation in construction and operation and maintenance. So it has been taken care while construction that the beneficiary farmers are involved in a maximum mode. Besides this, water management above, at and below the farm level, because it is already, as I explained, the canal network is very big. The main canal carries over 40,000 cusecs of water. It is more than a medium rivers. So from that water flow at field level, around 1 cusec or less flow is being handled by entire network. So it is the management at the canal level and at the field level and at minor level is very crucial, very tough, I think. Then reclamation of waterlogged and problematic areas. There are about 2 to 5% area which is prone to waterlogging. And presently there are some area, some pockets which is already having waterlogged condition. So we are reclamation measures are being taken. Now, because of the geographical condition of the area, topographical condition of the area, the relief is least. So surface drainage possibility is very difficult. In that case, R&D on biodrainage is also being undertaken. Then demonstrations and training programs. We are running demonstration and training program at 12 centers in collaboration of state agricultural universities. So their experts are providing help in carrying out demonstration and training to the farmers. Strengthening of monitoring and evaluation mechanism. So we are already, as I explained, we have a setup for soil and water quality monitoring. We call it as a soil survey units. We have 7 subdivisions and 2 divisions in entire command area to carry out this activity. Emphasis are being made on data collection and analysis and dissemination also. These are some of the thrust area we are looking after. Now, what is the pins, how we intend to do it? Say this is a view of a chuck area below the outlet, and the pipeline network as shown, underground pipeline network as shown is already created in almost in the entire command area. So this would be the the model. This is in Rajasthan, they have followed. And we have also the underground pipeline up to this. So this would be like this pressurized network. So there would be a sump having pumping unit, and then main pipe, distributory pipe, and then up to fill, the entire pipe network is provided. Then at field level, we have an agency, as you know, Gujarat Green Revolution Company, which promote adoption of drip irrigation and provide subsidies to the farmers. So at field level, in the installation of a micro irrigation system is being looked after by Gujarat Green Revolution Company. Now, the micro irrigation system is adopted in Rajasthan, part of the command area. So I would just bring under your information about what is being done there. Now, Narmada main canal, about 70 kilometers, is in Rajasthan. Original CCA was 1.35 lakh hectare, and then by adoption of MIS, micro irrigation systems, mainly sprinkler system is adopted. Now the command area is increased to 2.46 lakh hectare. So almost very near to double the area. And they have the system of irrigating on both the sides. In normally command, we have the gravity flow. So mainly canal covers on one side area for irrigation, but in Rajasthan, the adoption is on both the sides because there is the micro irrigation system and pumping system is provided. So the system is distributary to minor, then a diggy. They use call it as a diggy. That is a storage of water for irrigating through pins. Pins, as I shown you the pipe layout, is a pins and coupled with the sprinkler system in the field. They have the VSA, they call it a VSA of the area of 80 to 100 hectares. So their unit is small as compared to the units planned in Sardar Sarovar project in Gujarat region. And cost of pins at that time in the year 2010 was 25,000 per hectare. I think this cost is not much as compared to the cost of the irrigation facility being created. Normally, 3 lakhs to 5 lakhs rupees investment for creating irrigation potential in 1 hectare area is at present. So compared to that cost, this cost is not much. Now this is a view of a diggy from the outlet of the minor and a pump unit installed in Rajasthan. What intended in our project is like this, to create a storage near canal and then a pumping unit with filtration and everything, followed by pins, pipes, and then to the field. This is an existing trial storage created in the command area near Hadwat on pilot basis. A minor is selected and it is being tried to cover under the micro irrigation system. So individual farmers, they have created their own storage as shown. And from this place, the water is delivered in the storage, and from this, farmers used to take water by their own pumping unit coupled with the micro irrigation system. They use this type of portable oil engine where the electricity is not available, and coupled with filter unit in the field itself, and followed by installation of micro irrigation system in the field. Now, expectations. You see, what is expected from all this? we expect the empowerment of the farmers for participatory approach, because what is needed is better system maintenance and services. After all the creation of the infrastructure can be created, but the maintenance and operation is a limiting factor. So for that purpose, farmers participation is a need, is a must, and for that purpose, and by that only we can have the better maintenance and services, then reducing the cost of irrigation to the government, because government, the operational cost is very high normally in all irrigation projects. So it's an issue to address that. Participatory approach or participation of the farmers is very much required. Also attending higher productivity and profitability. You know why we are doing all these things, why we go for irrigation facility creation, and then how we are trying so much of efforts, we are putting so much of efforts and money for managing that irrigation water. All is behind the main objective, main target or task is to have higher productivity and profitable agriculture. So for fulfillment of this expectation, what is to be done? As we discussed, the empowerment of the farmers for planning and implementation of water distribution network. You see, minor and below distribution is a very crucial, and for that, as per the planning, it is to be handled or managed. Water is to be managed by farmers association, so-called water user association, right from water distribution. Also, they have to carry out OFD works in majority of the command of the country. This OFD work is being carried out by government, but in case of Sardar Sarovar project, this is to be done by farmers themselves. So expected that farmers carry out OFD works, that is field channels, field drains, and land leveling and land development works, including bunding and leveling, everything. And the last but not least, the crop management. You know, managing crop in the irrigated command is also very important. So that is also to be done by the farmers. So farmers must be empowered for better crop management. Then development of MIS feedback system. A system must be there in place to monitor and evaluate as well as maintenance and repairing. Without this, the sustainable operationalization of the project is impossible. So this is also and that is to be done by farmers themselves. A system, a government or any official control over this would be at very high cost, and that is why the farmers must be empowered. And promotion of livelihood support system and implementation of on-farm innovation is a need, because continuous efforts, continuous persuasion of the farmers followed by facilitation to them show that they can enhance their livelihood support system in total, and their socio-economic condition become very sound, so that they can do farming better and can produce more and can give better benefit or better contribution to the GDP. And that is why and for that, implementation of on-farm innovation is equally important. From time to time, they have to change the farming practices and all other innovations to be employed. So for that purpose, we need to empower the farmers. And what is the bottlenecks now? We could understand that we can have a better conveyance system, better network of the canal system. We can have control structures also. We can allot water as per volume, as we call it as a volumetric water supply. We can have rotational water supply by farmers themselves by giving them authorized for distributing water from minor and below. We can also do extend the support of finance by providing subsidy for installation of micro irrigation system. And as far as the Sardar Sarovar project is concerned, we have already installed underground pipeline up to 5 hectare, 5 to 6 hectare subchap at the cost of government. So all this we can do, but after all, in spite of that, there are many issues to achieve, in between to achieve this target. That is, first we can say inadequate availability of water. See, as I briefed you, maximum potential of water harvesting, water availability is 9 million acre feet in the share with the Gujarat. And that too, when there is less rain in catchment area or less water available in catchment area. So availability at field level becomes very inadequate. Inequality in distribution of water, as it happened in almost all commands in the country or in the world over, the distribution is in tailend is a problem. So tailend people are always deprived of the availability of water. So inequitable distribution is an issue. Then damaged structure and unauthorized outlets. You know, the canal network is a very big and so many numbers of structures. So, and they get damaged or there are lot of unauthorized lifting of waters or outlets. So it is difficult and it is an issue how to prevent them. And very most important is the managing the cropping pattern. You know, there is always conflict between farmer's choice and the government's requirement, our requirement. You know, if people adopt crops like paddy, sugar, etc., they can earn more. They are earning more by adopting these crops. And that's why they are just shifting when the water is available through canal, they are shifting towards these two crops. But our requirement is just reverse. We need to produce at least utilization of water. So we need more water use efficiency, more production per unit utilization of water, while the farmers need to earn more, and for that they go easily with the paddy and sugarcane. So these conflicts management and adoption of proper cropping pattern is crucial. Besides this, there are some technical issues also. Minimum rehabilitation and renovation of the canal system, how to do? Because always if we go for repairing and rehabilitation and renovations, the work go on continues and the real benefit as a net return will be deducted. So there should be minimum of that. Then lack of fund and technical support. This is also because extending such an technical support up to the level of farmers, or if we talk about think about the Sardar Sarovar project, then up to over 3,000 water user association is a difficult task. Then lack of information about water release and quantity and time, because Jarai and Barai, as you know, water takes certain time after the opening the gate. Also, it takes certain time after the closing the gate to seize the flow. So all this is issues, and how to manage in a big project area is also a crucial thing. Then there is absence of speedy communication facility. So these are some technical issues. Besides that, there are economic issues also. Need of increase in agricultural production. Now, up till now, the productivity we intend to double, which is quite far. Then over financing is also a constraint, because farmers have now they are expecting everything. As we have just installed pipeline at the cost of government up to 5 hectare. Now they are expecting that we extend it up to their field. So the expectations goes on increasing, and because of that, the financial over financing is also a constraint, and then lack of linkages. So many agencies are working. So linkage is a crucial issue, or it is an economic issue. Then legal issues also. Increasingly farmers feel. So farmers, what they feel, they always need some help. They always feel for requirement. So that is a, and also some in many cases when they have to give, they become, and they have so many conflicts also. So feel is a problem. They must feel good, and it is an essential part, a basic thing. So it is an issue. Then water fee collection. See, sometimes collecting the water charges is not smoothly functioning, and it's recovering this water charges is more than the amount recovered. So this is a thing which is to be considered. Now, what is the solution? As per our experience, the participatory approach that provide framework for decentralized decisions making to the lowest level and allow beneficiaries and other stakeholders to be involved is a key success of development for sustainable irrigated agriculture and maximization of benefits of irrigation projects while protecting the environment. This is the solution we find. Or participation of the farmers is a crucial. Their involvement, fully involvement, and must be empowered for decision taking. And that too, the farmers in the tail end locations. So friends, I have just briefed. This is a very big topic, and pins and MIS is more or less a technical thing, and as a design aspects, I have just give you an overview how we are planning to adopt these pins plus MIS in the command area, and what are the actual issues and how we can get success. This all I have bring under your information. Now I just offer the question and interaction on this. Each and every topic is having a very big area of expectation for information. So in specific, I would like to provide more information as per your requirement, as per your questions. Thank you very much. Hello.
Thank you, sir.
Sir, I have question. In this sump, from the photograph, it seems that depth of sump is less and water spreading area is large. So
This one?
Sump which you have shown
This one?
What is depth of that sump?
Yeah, you see, this is initially we have just refined this design as the farmers were adopting. So this is just a retuning or reconsideration, little incorporation or reconsideration of the farmers' design. So this is basically done by the farmers at least cost and as per their own practices. So I agree with you that surface area is bigger. Also, you are seeing the algae also and some dust and all other. So cleaning is a problem in such a sump. So critically, this would be further, I think, reconsidered to design smaller size of the sump and with a higher depth. And for that purpose, farmers would be provided. I think primers can be provided with some part as a subsidy so that they can afford the cost. Because as we go for increasing the depth, the cost would be increasing. Also, pumping cost would also increase. Both would be compensated, could be compensated by providing appropriate financial support. So this is what intended is.
Sir, can we think solar panel on the surface of the this sump so that that energy can be used for the pumping for the pin system and also
So,
help
Yeah, this is also planned, and we have a pilot project in Sankeshwar. That is the most problematic area, as I said you. The groundwater and soil quality is a problem in that area. Drainage is a problem. Water remains inundated for 2-3 months in the rainy season, and it is in the vicinity of Little Run of Kutch and in tail end of the command. So that problematic area we have selected, and we are carrying out a pilot project entitled as land reclamation and comprehensive development of agriculture, wherein we have already registered a entire feeder for this electricity solar power utilization, already registered and approved.
Sir, there is one question from engineer Chirag. He is asking storage system standard dimension and also the capacity. What is the capacity for 20 hectare is size?
Capacity of storage. Sump. Yeah, see, capacity of the sump is determined, as we know, we have the system, as in the beginning itself I have bring a slide that we have the canal operation 7 days on off. So when the canal is on, the storage is much requirement is not much, but the actually crucial consideration for storage creation is during the off of the canal. So for 7 days, if we consider 2 days pre and past, then middle 4 days requirement of the crop is being stored, is being planned to store in a local storage. So 4 days requirement, and that too depends upon the crop. Mainly the major crops is cotton in 40% of the area of the command area, but it depends on the location where which type of crop is being grown. If there is a gram, then there is no need of much storage. No need, almost not need. So a small storage is enough. But if there is a cotton, then we have to provide the daily requirement of crop water requirement for 4 days storage.
The participant, you can put your question in the chat box also if you don't want to ask directly. Sir, there is one question from Anis Mohammed. What is the state of contamination level of main canal in Gujarat?
State of
contamination.
Contamination. Okay. So far not. We are observing canal water quality of main canal also, and so far we have very good water. Even you will be happy to note that TDS is also very much controlled. But we are planning further to have a system. Even yesterday itself we had a discussion that how to clean these big canals. You know, it's a small river size. So how to clean, how to remove the debris and the soil and the algae, everything in the canal, and it is being planned to make it clean from time to time, and with the help of mechanization only, so it can be done better.
Participant, any question? I think we are lucky that we are having the person who is hybrid of academic and field. He is multi-level experience in the field as well as the academic experience. So we should take benefit of him. Sir, there is one question, I think, from the same Anis Mohammed. Do government undertake any massive filtration system of canal like the system followed in Australia?
Can you repeat, please?
Do government undertake any massive filtration system of canal like the system followed in Australia?
Filtration system. Oh, see, in the as the science is advances, the application and adoption in the field itself is also taking place. In the Narmada Canal network, there are already the structures, so-called sill trapping structures, So the sill trapping structures are already provided at certain intervals on entire canal network. By that, cleaning from time to time is being carried out. So that is done. But filtration system like Australia, I think so far not considered or not thought for.
Another question from engineer Chirag. Plastic line farm ponds can be advisable?
Yeah, that is where the cost is required to be reduced, and if farmers is agree, now in North Gujarat, many farmers are adopting pond construction with plastic line, so it is possible, and it is easy and least cost. The only thing is little maintenance is required. If farmers himself do, then it is better.
There is one question, sir, that is of student level. So let me ask, the slope of canal generally 1 meter in 2000. So this is not question level of question from Marve side. So I am answering it. There is one question from Ina Bhatu from RK University. Any subsidy for farm pond from government?
Sure, pond construction always having some subsidy through the program of say watershed development program, and it was with the GLDC also. They were providing subsidy for farm pond construction. Presently, the GLDC is under the reformation of structure, so it would be available within short.
Sir, I have a question. In the India, we are striving for the construction of small and big dam. In the advanced countries like USA, the big dams are being demolished, which has been constructed before 100 years. So, can this situation will arise here also in India in later on, or there is no threat for this?
I think the studies have revealed that small structure is always giving more return and more beneficial. But as far as this issue is a very high-level policy issue and can be dealt with that level of persons. But I can just bring under your information about the cost of this project, our project. See, we have crossed about 68,000 crores of investment for creating 18.46 lakh hectare area under irrigation facility. So if you see per hectare cost is very high. When we consider interest, then incremental production should exceed the interest cost at least. If we add the maintenance, repair and maintenance of the project by providing infrastructure and staff, again the cost increases. And if all together we consider the cost benefit, I think bigger projects are smaller structures are more advisable than the bigger one. It appears like that. But at the same time, when there is a scarcity or drought area or drought years, the small structure also are not receiving or not receiving any or availability of water is a problem at that time. So during scarcity, big structures is very much required, and it is just like life saving. So on both the sides, if you consider just in a simple way cost only, then simple consideration is this, that smaller structures are better. But when we consider the calamity and these droughts and all this, then in that case, the availability of water is a crucial. So how and where we have to take our path is a question, and it is very high level question, policy level question.
There is another question from Dhakkad, I think. He's asking about the reasons behind Chamoli Glacier break. See, Dhakkad is the Chamoli Glacier broke around 18 kilometer upper side of the project, not at the site of the project. One thing. Second thing, there are so many reasons for glacier break. One may be, yes, people are saying that this year the snowfall is less, so the weight of snow is less over the land, and landslide is there, so all snow has gone with the landslide. There may be so many reasons. We don't know there what happened. If things will come, but as far as the due to the project, it is doesn't look that because the project is 18 kilometers away from the site from where the glacier broke, and in fact, the whatsoever debris that has come, that has taken care by the thermal power project. Otherwise, it could have gone in downstream and made havoc in the downstream. The thrust has taken only thrust by the thermal power project, and only some part of the mud and other jet thing has gone with the river downstream. So the things will come. It's a big question. Answer will come. So many answers are possible in future. Thanks. And one more question, sir, from our student, that any SSNL, the IoT based smart irrigation used
Pardon, please.
in Sardar Sarovar, IoT based smart irrigation system is used anywhere?
A very nice question. See, after having visit of a delegation of government of Gujarat to Israel, Israel government is committed to donate 2 sets of for digital farming, 2 latest equipment set. So with the use of that, we have already planned for digital farming pilot projects. One in Halwad, which I have shown you the minor model VSA. There we are going to install this one, where the entire digital what we can say farming will be tried. So 2 pilot projects we are just considering to undertake shortly for smart farming.
So, sir, now there is no more questions. So thank you for a nice lecture to the students and giving your time for this vocational training. Thank you, Professor Maravia, sir. Thank you.
Thank you all.
Namaskar, sir. Next.
हाँ बोलो. हाँ हाँ हाँ.
How? Introduction. બધું ટેકનિકલ વસ્તુ જ છે, બીજું કઈ નહીં. એટલે આપણે એમાં
Dear friends, we are with Yes Prakash. Yes Parekh. He is working in NAHEP-IDP India Limited. He is
Executive Digital Farming Solution.
he is Executive Digital Farming Solution, NAHEP-IDP India Limited, Vadodara. He is expert in automation programming, fertigation, automatic irrigation, scheduling based on weather, sensor, and volumetric based, time based. So all these he is expert. He is responsible in the company for strategy formulation to improve sales and market share for the digital farming solution of the automatic product. He is also responsible for dealing with privileged customers, starting from taking orders to delivery for crop management technology, meeting existing customers and new target customers and converting them into customers. He performed frequent and effective networking with a variety of business partners and customers. Also updating sales team and dealers about any change in the product as well as the competitors' activities and new opportunities in their territories. He is responsible for coordinating with the dealers of the company and dealer analysis. Involved in solving the problems and technical queries of the customers. He also organizing events at the dealers' place to attract more customers and arranging farmers' food product demonstration in the exhibition in a farmers meeting. So Parekh, he is BTech in agriculture, electrical engineering. So participant now let us take his benefit. You can ask the question in the during the presentation also. And now I request Yes Parekh to start his presentation.
Hello, good morning everyone. Can anyone hear me?
Yes.
Can you hear? Okay, so let's start. Good morning. I am Yash Parekh from NAHEP-IDP Vadodara. Today's our topic is about the components of automatic drip irrigation systems. मतलब कि हम जो ड्रिप इरिगेशन करते हैं उसमें ऑटोमेशन में कौन से कंपोनेंट्स यूज करते हैं उसके बारे में आज हम डिस्कस करेंगे. तो उसमें मेन जो अपने कंपोनेंट्स है उसमें सबसे पहले तो
on your camera also. Yes.
Yeah.
So that participant can see.
On your camera also.
Here some official work is going on, so I will start with after 5 to 10 minutes.
Okay.
Is it okay? Okay, thank you. So first of all, let's talk about some major parts, components which use in automation. So controller is the heart of the systems. अगर आप irrigation करना चाहो, fertigation करना चाहो, कुछ भी हो, controller is the main product which we require to use in the automation. लेकिन उसमें क्या है कि हम कंट्रोलर में हमें देखना पड़ेगा कि उसमें कौन से टाइप्स आते हैं, कौन से फीचर्स है, तो उसके लिए एक अलग से सेशन रखा हुआ है. तो आज हम जो डिस्कस करेंगे उसमें कंट्रोलर को छोड़ के बाकी सारे कंपोनेंट्स जो ऑटोमेशन में यूज होते हैं उसके बारे में डिस्कस करेंगे. Just a minute. हमारा जो एजेंडा है आज का, उसमें हम पहले नेटाफेम का इंट्रोडक्शन दूंगा कि नेटाफेम क्या है, कंपनी कब स्टार्ट हुई, कैसे ड्रिप इनोवेशन हुआ। फिर बाद में हम देखेंगे कि ड्रिप इरिगेशन की क्यों रिक्वायरमेंट है, हमें ड्रिप इरिगेशन क्यों करना चाहिए। उसके बाद कंपनी का विजन, मिशन और पर्पस के बारे में बात करेंगे। उसके बाद नेटाफेम की प्रेजेंस एंड स्ट्रेंथ के बारे में बात करेंगे। और बाद में स्मार्ट इरिगेशन, डिजिटल फार्मिंग के जो कंपोनेंट्स हैं वो देखेंगे, और उसका जो सॉल्यूशन है आपकी रिक्वायरमेंट के अकॉर्डिंग, कौन सी सिस्टम आपकी रिक्वायरमेंट है तो कौन सी सिस्टम प्रोवाइड करनी चाहिए, उसके बारे में बात करेंगे। तो सबसे पहले मैं बताना चाहूंगा कि ड्रिप इरिगेशन का इनोवेशन कब हुआ। तो 1965 में ड्रिप इरिगेशन इनोवेट हुआ। तो ड्रिप इरिगेशन क्यों करना चाहिए, और ऐसा क्या हुआ कि उनको पता चला कि ड्रिप इरिगेशन से जो है हम बेटर इरिगेशन कर सकते फ्लड की जगह। तो उसके लिए मैं एक वीडियो है वो आपको शेयर करना चाहूंगा। शायद आप लोगों ने ये वीडियो देखा होगा, कई लोगों ने। तो जैसे कि वीडियो में हमने देखा कि 50 इयर्स पहले ड्रिप का इनोवेशन हुआ, जब उन्होंने देखा कि एक पाइप जा रही है, वहाँ पे कुछ लीकेजेस हैं, और वहाँ पे जो ट्रीज है उसका ग्रोथ बाकी ट्रीज के कंपैरिजन में ज़्यादा है। तब उन्हें पता चला कि कुछ ये करते हैं कि इसको ड्रिप के थ्रू, मतलब कि ड्रॉप बाय ड्रॉप इरिगेशन करते हैं। तो उसके बाद तब से 50 इयर्स पहले 1965 में ड्रिप का इनोवेशन हुआ, और तब से जर्नी स्टार्ट करके आज तक हम उसमें जो भी चेंजेस है वो करके उसको मोर एफिशिएंट बना रहे हैं और ड्रिप कर रहे हैं। अभी ड्रिप तो हम कर रहे हैं, लेकिन हमें क्यों करना चाहिए? ठीक है, पानी का सेविंग्स होता है, जो ग्रोथ है वो ज़्यादा अच्छी होती है, बेटर यील्ड आती है, लेकिन हमारे पास जो रिसोर्सेज हैं अभी प्रेजेंट में वो लिमिटेड है। जो भी फूड स्कैरसिटी है, लैंड है, वाटर है, वो लिमिटेड है। लेकिन उसके साथ में हमारी जो पॉपुलेशन है वो दिन प्रतिदिन बढ़ रही है। तो एक अनुमान के अकॉर्डिंग जब 2050 तक वर्ल्ड की जो पॉपुलेशन है वो 9.3 बिलियन तक पहुंच जाएगी, और उसके सामने जो हमारे सोर्सेज हैं वो लिमिटेड है। तो हमें क्या ऐसा करना चाहिए, और नेट एफएम उसमें क्या अपना योगदान दे सकती है, इसके बारे में हम बात करेंगे। तो अबाउट द वर्ल्ड पॉपुलेशन डिमांड एंड इट्स अपॉर्चुनिटी इन द वर्ल्ड। So this is one another video I would like to share. अभी नेट एफएम के विजन मिशन और पर्पस, कोई भी कंपनी होती है उसके विजन मिशन और पर्पस रहते हैं। तो उसका जो पर्पस है नेट एफएम का, उसकी बात करें तो हेल्पिंग द वर्ल्ड ग्रो मोर विथ लेस। पूरे वर्ल्ड को जो है हेल्प करना है लेस के साथ ग्रो ज्यादा मोर होने में। और विजन क्या है? As the world's leading irrigation company, we will drive mass adoption of smart irrigation solutions to fight scarcity of food, water, and land. मिशन की बात करें तो together with our partners, we will drive revolution irrigation globally for a sustainable future. We will drive mass adoption of innovation, simple and reliable drip irrigation solutions. Our team around the world will provide customer with the best agronomic supports and technical supports to ensure outstanding results and peace of mind. जैसे कि आप लोग जानते होंगे कि नेट एफएम जो है वो वर्ल्ड में फर्स्ट नंबर की इरिगेशन कंपनी है, लार्जेस्ट इरिगेशन कंपनी इन द वर्ल्ड, पायोनियर्स एंड लीडर्स इन ड्रिप इरिगेशन रिवॉल्यूशन, ऑफरिंग एंड टू एंड स्मार्ट इरिगेशन सॉल्यूशंस। और नेट एफएम इंडिया की बात करें तो उसका जो हेडक्वार्टर है वो गुजरात में बड़ौदा में है। नेट एफएम इंडिया इज हेडक्वार्टर इन गुजरात बड़ौदा एंड इट इज द लार्जेस्ट सब्सिडियरी ऑफ नेट एफएम लिमिटेड इजराइल्स। We have 3 manufacturing plants facility, 2 plants is in Vadodara and 1 at Chennai, Tamil Nadu. जो हमारा वडोदरा में दूसरा प्लांट है उसका इनॉग्रेशन श्री नरेंद्र जी मोदी द्वारा किया गया था 2012 में। नेट एफएम की स्ट्रेंथ की बात करें तो मार्केट लीडर विथ स्ट्रॉन्ग ब्रांड, कटिंग एज इनोवेशन टेक्नोलॉजी, full portfolio of end-to-end smart irrigation solutions, broad global coverage with strong distribution network, leading agronomic and technical knowledge, state-of-the-art manufacturing standards, over 4,000 employees globally, और इंडिया में अगर बात करें तो 1,000 प्लस एम्प्लॉयज इन इंडिया, और 50 years ओल्ड कंपनी है तो उसके पास एग्रोनॉमिकल डेटा, एग्रोनॉमिकल सपोर्ट्स और जो भी इसके लिए टेक्निकल सपोर्ट चाहिए वो सब है। अभी नेटाफेम की हिस्ट्री की बात करें तो 1989 में नेटाफेम ने बिजनेस स्टार्ट किया था इंडिया बेस्ड छल बिंदु एग्रीटेक के साथ में, बॉम्बे बेस्ड था। तो 1989 में स्टार्ट हुआ। फिर 1997 में एक्सल क्रॉप केयर, अभी जो एक्सल इंडस्ट्रीज है उसके साथ जल बिंदु, नेटाफेम और एक्सल तीनों को साथ मिलके जो है बिजनेस स्टार्ट हुआ। उसका रीनेम किया गया एज एक्सल ड्रिप एंड एग्री सर्विसेज प्राइवेट लिमिटेड। फिर 1998 में एक्सल ड्रिप एंड एग्री सर्विसेज प्राइवेट लिमिटेड रीनेम एज नेटाफेम इरिगेशन इंडिया प्राइवेट लिमिटेड। 1998 में नेटाफेम का जो नाम था वो नेटाफेम इरिगेशन इंडिया प्राइवेट लिमिटेड कर दिया गया। फिर 2002 में जो है फर्स्ट मैन्युफैक्चरिंग प्लांट इंडिया में ओपन हुआ बड़ौदा में, गुजरात में, और यही उसका हेडक्वार्टर है, बड़ौदा गुजरात। 2005 में जब जीजेआरसी शुरू हुई तो काफ़ी जो है उनका रोल था, की रोल ये किया। और 2008 में सेकंड मैन्युफैक्चरिंग प्लांट इनोग्रेट हुआ, वो जो है वो चेन्नई तमिलनाडु में हुआ। 2009 में यहाँ पे एसबीयू फॉर्मेशन हुआ, मतलब कि जहाँ पे एक ही साथ जब लोग बढ़ते गए, कंपनी का डेवलपमेंट होता हुआ, वैसे उसके बाद में एसबीयू बिजनेस यूनिट्स आए। अभी प्रेजेंट में यहाँ पे 3 बिजनेस यूनिट्स हैं, एसबीयू वेस्ट, एसबीयू सेंट्रल और एसबीयू साउथ। साउथ के जो स्टेट्स हैं तमिलनाडु, केरला, वो साउथ में हैं, एसबीयू साउथ में अंडर में आते हैं। एसबीयू सेंट्रल में महाराष्ट्र, फिर एमपी और छत्तीसगढ़, वो सब जो है वो एसबीयू सेंट्रल है। और गुजरात, पंजाब, हरियाणा, हिमाचल जो है वो एसबीयू वेस्ट एंड एसबीयू नॉर्थ हुआ। 2011 में नेटाफेम इंडिया जो है वो नेटाफेम की लिमिटेड की सब्सिडियरी, नंबर 1 सब्सिडियरी ग्लोबली बनी। 2012 में सेकंड प्लांट जो है वो थर्ड प्लांट हमारा यहाँ पे ओपन हुआ, इनोग्रेट हुआ। 2013 में एशिया का जो है सबसे बिगेस्ट प्रोजेक्ट रामथल कर्नाटका, जिसे कम्युनिटी इरिगेशन कहते हैं, वो नेटाफेम को मिला। उसके बाद 2014 में 4 डिवीजन हुए नेटाफेम, एक इरिगेशन, ग्रीन हाउस, कम्युनिटी इरिगेशन और डीएफएस डिजिटल फार्मिंग सॉल्यूशंस, जिसके बारे में आज हम डिटेल्स में बात करेंगे। 2016 में तेलंगाना अरवल्ली में एक बहुत बड़ा प्रोजेक्ट हुआ, मिला। उसके बाद 2017 में नेटाफेम में जो है उसको एक्वायर किया मैक्सिकेम ने। ये जो मैक्सिकेम है वो मैक्सिको बेस्ड कंपनी है, और 2017 में उसमें ज़्यादातर जो स्टेक है वो नेटाफेम का मैक्सिकेम ने एक्वायर किया। और उसके बाद 2018 में उसका जो नाम है मैक्सिकेम, उसकी जगह पे और भी किया गया। और ऐसे ही कई सारे सीआई के प्रोजेक्ट्स और बड़े बड़े प्रोजेक्ट्स मिले। वो ग्लोबली जो अगर प्रेजेंस की बात करें तो 16 मैन्युफैक्चरिंग प्लांट्स हैं ऑल ओवर द वर्ल्ड, 29 सब्सिडियरीज हैं और 110 कंट्रीज में ऑपरेशन जो है उनके हैं। ये कुछ प्रेजेंस हैं जिसमें वेयर हाउसेज, रीजनल ऑफिसेज, हेड ऑफिस और मैन्युफैक्चरिंग प्लांट कहाँ कहाँ पे है उसका दिखाया गया है। इंडिया में टोटल 3 मैन्युफैक्चरिंग प्लांट्स हैं, उसमें से 2 वो प्रोवाइड्स करते हैं। 9 मैनेजमेंट है, एसबीयू के हेड्स हैं, सीआई प्रोजेक्ट्स के जो हेड हैं वो है। 286 अदर स्टाफ है लाइक प्लांट्स एंड सपोर्टिंग स्टाफ्स। 55 जो है वो डिजाइनर्स हैं। ये 483 जो हमारे सेल्स एंड मार्केटिंग स्टाफ है वो भी डिजाइन करते हैं, लेकिन 55 जो है स्पेशली डिजाइनर हैं। और उसके साथ में पूरे वर्ल्ड का जो ग्लोबली डिजाइन सेंटर है वो इंडिया में शुरू हुआ है, नेटाफेम लिमिटेड का। तो वो पुणे बेस है और वहाँ से सारी डिजाइन्स होती हैं। तो ग्लोबली जो है यहाँ पे डिजाइन्स बनती है इंडिया में, पुणे में। अभी बात करें डिजिटल फार्मिंग सॉल्यूशंस की, तो ऑटोमेशन इन एमआईएस, डिजिटल फार्मिंग सॉल्यूशंस। डिजिटल फार्मिंग क्या है? जो भी हम ड्रिप इरिगेशन में ऑटोमेशन करते हैं उनको पहले जो था वो हम CMT बोलते थे, क्रॉप मैनेजमेंट टेक्नोलॉजीज, क्रॉप को किस तरह से यील्ड बेनिफिट्स कर सकें। उसके बाद उसका जो नेम है वो चेंज करके अभी डिजिटल फार्मिंग किया हुआ है। तो डिजिटल फार्मिंग सॉल्यूशंस की बात करें तो हमें ऑटोमेशन क्यों करना चाहिए, ऑटोमेशन की रिक्वायरमेंट क्या है और ऑटोमेशन है क्या। तो जो भी वर्क हम करें उसमें मैन्युअल इंटरप्शन ना हो उसे हम ऑटोमेशन कहते हैं। अगर सिंपली ड्रिप इरिगेशन के ऑटोमेशन की बात करें तो ड्रिप इरिगेशन में क्या ऑटोमेशन करेंगे हम। सिंपली अगर जो आपके मन में सबसे पहला ख्याल आए वो है कि ड्रिप इरिगेशन में हम क्या करते हैं, तो मैन्युअली पंप ऑन करते हैं, फिर वाल ओपन करते हैं, फिर अगर तो जिसमें भी मैन्युअल इंटरप्शन जितना कम हो उसे हम ऑटोमेशन कहते हैं। तो उसमें बात करें तो वाटर पंप का ऑटोमेशन हुआ, फर्टिलाइजर पंप का ऑटोमेशन हुआ, और अब जो वाल्व्स फर्टिलाइजर पंप का ऑटोमेशन और यूज करते हैं फील्ड में, यहाँ पे जो भी वाल्व्स इलेक्ट्रिकल वाल्व ऑटोमेशन में यूज हुआ। तो बेनिफिट्स क्या है ऑटोमेशन के, ऑटोमेशन तो हम करेंगे तो उसके बेनिफिट्स क्या हैं। तो अगर आपको नाइट में इरिगेशन करना रहा या फिर आपका जो पावर टाइमिंग है वो उस अकॉर्डिंग रहा, तो आप कोई भी टाइम पे उसको प्रोग्रामिंग करके नाइट इरिगेशन, डे इरिगेशन कर सकते। अगर आपका एक से ज्यादा इरिगेशन पंप रहे, सपोज आपका बड़ा फील्ड रहा, तो कोई जगह पे आपको 2 इरिगेशन पंप यूज करने पड़ेंगे, कोई जगह पे एक यूज करना पड़ेगा। तो मल्टीपल्स पंप यूज करेंगे तो हर एक बार जगह पे आपको मैन्युअल इंटरप्शन नहीं करने के लिए जाना पड़ेगा, एक पंप को ऑन करने के लिए, दूसरे पंप को ऑफ करने के लिए। तो मल्टीपल्स पंप जो है वो हम प्रोग्रामिंग कर सकते हैं। वाटर की एफिशिएंसी और फर्टिलाइजर का यूज प्रॉपरली कर सकते हैं, प्रॉपर उसको टाइमिंग से हमारी जितनी रिक्वायरमेंट है उतना प्रोग्राम कर दिया तो उतना इरिगेशन और फर्टिगेशन जाएगा, तो उसमें सेविंग्स होगी, लेबर की कॉस्ट सेविंग कर सकते हैं। क्लाइमेट कंट्रोल जो ग्रीन हाउस में हम करते हैं, ग्रीन हाउस और नर्सरीज हैं उसमें टेम्परेचर कंट्रोल करते हैं, ह्यूमिडिटी कंट्रोल करते हैं, फिर लाइट्स, पावर लैंप, बूम इरिगेशन करते हैं। तो बहुत सारी चीज इसके ऑटोमेशन के थ्रू हो सकती हैं। इम्प्रूव्स क्वालिटी एंड कंसिस्टेंसी ऑफ क्रॉप, आपका जो भी क्रॉप्स आएंगे इरिगेशन हुआ है उसकी क्वालिटी और कंसिस्टेंसी एक जैसी रहेगी। इंक्रीज यील्ड्स एंड कॉस्ट इफेक्टिव, और आपने अगर इस बार ऑटोमेशन का यूज किया और आपको लगा कि इस बार जो है मुझे क्रॉप जो है वो बेटर मिला, तो अगले साल आपको सेम उस टाइप का डेटा चाहिए कि आपने पिछले टाइम कितना इरिगेशन किया था, कौन से टाइम से स्टार्ट किया था प्लांटेशन के बाद, कितने दिन बाद कितना वाटरिंग किया था, कितना फर्टिगेशन किया था। तो वो पूरा मॉनिटर करके उसका डेटा जो है वो स्टोर कर सकता है। तो आप उनका फ्यूचर में भी यूज करके मैक्सिमम यील्ड्स ले सकते हैं और उसके अकॉर्डिंग आप प्लान कर सकते हैं। ड्रिप इरिगेशन ऑटोमेशन कम्युनिकेशन करना है, कुछ भी ऑटोमेशन का जहाँ पे नाम आता है वहाँ पे सबसे पहले हमें रिक्वायरमेंट रहती है कंट्रोलर की। तो कंट्रोलर कौन से टाइप के होने चाहिए, कैसी आपकी रिक्वायरमेंट है, इरिगेशन करना है, फर्टिगेशन करना है, क्लाइमेट कंट्रोल करना है, सेंसर बेस्ड इरिगेशन करना है, तो वो सारे उसके अकॉर्डिंग कंट्रोलर सिलेक्ट किए जाते हैं। तो कंट्रोलर के लिए एक अलग सेशन किया हुआ है। कंट्रोलर के अलावा और कौन से कंपोनेंट्स हैं वो हम देखेंगे और उसके बारे में डिटेल्स में बात करेंगे। तो कंट्रोल वाल्व, सबसे पहले जो हम बात करेंगे वो है कंट्रोल वाल्व। जहाँ पे आपके मैनुअल वाल्व्स आते हैं उसको हम वहाँ पे से मैनुअल वाल्व को कन्वर्ट कर देते हैं सोलेनोइड वाल्व्स में। उससे जो कंट्रोल वाल्व्स जो आपके मैनुअल वाल्व्स है वहाँ पे इलेक्ट्रिकल वाल्व लगेंगे और वो जो वाल्व लगेंगे उसको हम सोलेनोइड वाल्व कहते हैं, सोलेनोइड वाल्व्स। फिर उसके अकॉर्डिंग हाइड्रोलिक्स वाल्व, एसीडीसी टाइप। अगर आपके वाल्व रहा तो आपको वायरिंग करना पड़ेगा, उसके बारे में हम डिटेल्स में देखेंगे। तो वहाँ पे वायरिंग ना करना पड़े उसके लिए जो कंपोनेंट्स आते हैं वो यूज करेंगे। तो फिर एसी डीसी टाइप की उसके रिलेटेड उसको ऑपरेट करने के लिए सप्लाई उसकी बात करेंगे। प्रेशर रिलीफ वाल्व, जब आपका फील्ड पे प्रेशर बढ़ जाए तो आपका जो है डैमेजेस होने की चांसेस है फील्ड में, आपका हेड यूनिट पे प्रेशर बढ़ गया तो वहाँ पे हम ना ये डैमेजेस ना हो उसके लिए क्या कर सकते हैं, तो वहाँ पे प्रेशर रिलीफ वाल्व यूज कर सकते हैं, उसके बारे में डिस्कस करेंगे। वाटर मीटर्स, तो जो आप इरिगेशन कर रहे हैं वो कितना इरिगेशन किया, टाइमली आपने चला दिया कि आधे घंटे इरिगेशन करना है, 1 घंटा करना है, लेकिन उसमें आपका कितना पानी गया और आपके पर प्लांट रिक्वायरमेंट क्या थी। जैसे विंटर की सीजन रही तो पर प्लांट रिक्वायरमेंट अलग रहेगी, समर की सीजन रही तो पर प्लांट जो आपकी वाटर रिक्वायरमेंट है वो अलग रहेगी। तो आपकी रिक्वायरमेंट क्या है, कितना पानी आपको जरूरी है, उसके लिए हम जो है वाटर मीटर लगाते हैं ताकि हमें पता चले वॉल्यूमेट्रिक, उससे इरिगेशन कर सकते हैं कि आपकी पर प्लांट आपको रिक्वायरमेंट पता चल गई, इवापोट्रांसपिरेशन क्या है वो पता चल गया। तो उसके अकॉर्डिंग आप में बात करेंगे डोजिंग यूनिट्स की होते हैं। उसके बाद हम डिटेल्स में देखेंगे सेंसर्स, कौन से सेंसर्स यूज होते हैं। मॉइस्चर है तो मॉइस्चर के लिए सॉइल कंटेंट मॉइस्चर लेवल सेंसर यूज होता है। फिर टेम्परेचर ह्यूमिडिटी के लिए टेम्परेचर और ह्यूमिडिटी सेंसर्स यूज होते हैं। फिर सोलर रेडिएशन, इवापोट्रांसपिरेशन, टेम्परेचर, ह्यूमिडिटी, रेन सेंसर्स, उसके बारे में बात करेंगे। वेदर स्टेशन के बारे में बात करेंगे। और फिर मैनेजमेंट प्लेटफॉर्म्स, ये सारा आपने सिस्टम इंस्टॉल कर दिया, वाटर मीटर्स, डोजिंग सिस्टम्स, प्रेशर रिलीफ वाल्व, कंट्रोलर, लेकिन उसका आप मैनेजमेंट कैसे कर सकते हैं। ये सारी सिस्टम्स को आप किस तरह से देख रेख करके एक ही लाइन पे यूज कर सकते हैं, उसके लिए हम मैनेजमेंट प्लेटफॉर्म कौन से हैं, उसको किस तरह से मैनेज कर सकते हैं, उसके बारे में डिस्कस करेंगे। तो सबसे पहले देखते हैं वाल्व। वाल्व्स जो है वो 2 इंच, 3 इंच, 4 इंच, 6 इंच, 8 इंच, 10 इंच, 12 इंच, वैसे अपनी जो फ्लो की रिक्वायरमेंट होती है उसके अकॉर्डिंग आता है। अब कोई भी आप इरिगेशन चाहिए, कितना आपका एरिया है, उसके अकॉर्डिंग आपको वहाँ का फ्लो मिलेगा कि कितना आपको इरिगेशन की रिक्वायरमेंट है, कितना आपको वाटरिंग करना है। उसके अकॉर्डिंग हम वाल की साइज सिलेक्ट करते हैं। तो उसके अकॉर्डिंग 2 इंच के वाल है, 3 इंच के वाल है, 4 इंच के वाल है। ये जो है वाल के ऊपर, ये उसको यहाँ पे ये बटन है, तो ये क्या करेगा कि इसको कंट्रोलर के थ्रू कमांड मिलेगा, और जैसे ही कमांड मिलेगा ओपन, तो अपने आप ओपन होगा और क्लोज होगा। अभी सपोज आपको ऑटोमेशन नहीं यूज करना है, लेबर है उसके थ्रू आपको इरिगेशन करना है, कभी आप बाहर रहे और आपको ऑटोमेशन यूज नहीं करना है, तो आप इसको बाईपास भी कर सकते हैं। मतलब आपके पास फिर आपने मैनुअल वाल नहीं है, तो इसको यहाँ से रेड नॉब के थ्रू घुमा के ऑन और ऑफ करके उसको एज अ सिंपल वाल भी यूज कर सकते हैं। तो ये 2 इंच के वाल है, 3 इंच के वाल है, 4 इंच के वाल है, और ये है 3 वे वाल। 3 वे वाल क्या वर्क करता है कि ये हम वाल जो है वो बात की हमने फील्ड में लगाएंगे जहाँ पे हमें इरिगेशन करना है। 3 वे वाल कहाँ पे यूज होगा कि आपका जो फिल्टर रहा, आपकी जो फिल्ट्रेशन सिस्टम्स हैं उसको भी आपको ऑटोमेशन में यूज करना है। अगर आपको उसको मैन्युअली बैक वॉश नहीं करना है, उसको मैन्युअली क्लीन नहीं करना है हर रोज जाके, तो वहां पे आप फिल्टर्स का भी ऑटोमेशन कर सकते हैं। तो फिल्टर के ऑटोमेशन के लिए जो वाल यूज होते हैं वो 3 वे वाल्स हैं। तो ये 3 वे वाल हैं जो इरिगेशन का एक इन वन और आपका जो फिल्टर है उसकी इम्प्यूरिटीज है उसको बैक फ्लश करके निकालता है। तो वहाँ उसके लिए हमें 3 वे वाल यूज कर सकते हैं। वाल बोलते हैं, जैसे हमने यहाँ पे दिखाया कि मैनुअल ओवरराइड है, इसके ऊपर ओपन क्लोज और ऑटो का कमांड अपना टाइम और क्लोज कर सकते हैं। फिर ये जो है प्रेशर दिया हुआ है यहाँ, तो ये क्या करता है, प्रेशर रेगुलेटर का काम करेगा। अगर आपने इसको 2 kg पे सेट कर दिया तो 2 kg से आगे का प्रेशर आपके फील्ड में जाएगा ही नहीं। 2 kg से ज्यादा अगर प्रेशर हुआ तो वो बाईपास कर देगा, आपका जो हेड यूनिट है उस साइड प्रेशर रखेगा। मतलब आपके फील्ड के जो आउटलेट्स है, आपके वाल लगने के बाद आपका जो पाइप है, पीवीसी पाइप है, लेटरल है, वहां पे उसका प्रेशर जो है 2 kg आपने सेट किया हुआ है, तो 2 kg से आगे प्रेशर जाएगा ही नहीं। तो 2 kg से आगे अगर प्रेशर ज्यादा आया तो वो क्या करेगा, हेड यूनिट की साइड ट्रांसफर कर देगा प्रेशर, आपका आउट में प्रेशर नहीं देगा, हेड यूनिट की साइड ट्रांसफर कर देगा। अब हेड यूनिट की साइड ट्रांसफर करेगा तो क्या होगा कि हेड यूनिट पे प्रेशर बढ़ जाएगा, फिर वहां से कुछ डैमेजेस होने के चांसेस हैं। तो वो ना हो उसके लिए क्या करते हैं, वहां पे प्रेशर रिलीफ वाल्व क्या करेगा, आपने उसमें भी इस तरह से प्रेशर सेट कर सकते हैं कि 2 kg 3 kg 2.5 kg, अगर 2.5 kg बार पे आपने प्रेशर सेट किया पड़ेगा तो वहां से पानी बाईपास करना स्टार्ट कर देगा। मतलब कि आपको वहां पे मैनुअल प्रेजेंट रहने की कोई जरूरत नहीं है, चेस अपने आप बाईपास चालू कर देगा। ये हाइड्रोलिक्स वाल्व है, कुछ एयर रिलीज वाल्व है, और ये है प्रेशर रिलीफ वाल्व। यहाँ पे ऊपर जो नॉब दी गई है उसके थ्रू आप उसका प्रेशर सेट कर सकते हैं। अभी मुझे रिक्वायरमेंट है फील्ड में कि 1.5 kg या 2 kg से प्रेशर, यहाँ से इसको स्क्रू को जैसे ही टाइट किया और सेट कर दिया, बाईपास कर देगा। आपका जो प्रेशर है वो 2 kg से अप नहीं जाएगा, वो नहीं होंगे। बेनिफिट्स क्या है ये हाइड्रोलिक्स वाल्व के, वो रिलायबल है, उसकी डिजाइन अकॉर्डिंग उस तरह से की गई है कि वो लो हाई फ्लो पे हाई फ्लो पे और प्रॉपर वर्क करें, और इजी मेंटेनेंस है। उसका जो मेंटेनेंस है वो एकदम इजी है। आप देखेंगे उसमें ज़्यादा कुछ हाइड्रोलिकल पार्ट्स यूज नहीं हुए हैं, तो इजीली मेंटेन कर सकते हैं, इजीली उसका यूज कर सकते हैं। रिसेंटली एक नया यूजिंग मशीन ये, तो हमारी क्रॉप क्या है, फील्ड साइज क्या है, फिर कौन सा मीडिया है, ओपन फील्ड है, ग्रीन हाउस है, उसके अकॉर्डिंग हम डिफरेंट डिफरेंट डोजिंग सिस्टम्स यूज कर सकते हैं। अगर ओपन फील्ड है तो सिंपली अगर कॉटन क्रॉप रहा या कोई सिंपल क्रॉप रहा और छोटा फील्ड है तो 41 यूज कर सकते हैं। तो उसका सिलेक्शन कैसे करेंगे और इसमें क्या क्या बेनिफिट्स है, इसमें कौन से फीचर्स डिफरेंट डिफरेंट है, उसके बारे में अब हम डिटेल्स में डिस्कशन करेंगे। मॉनिटरिंग सिस्टम है वो है आर सेंस, टेंशियोमीटर और रेडियोनेट, उसके बारे में डिस्कस करेंगे। कंट्रोलर्स जो है वो है एनएमसी प्रो, एनएमसी जूनियर और एनएमसी नैनो, उसके लिए जो अलग सेशन है उसके बारे में बात करेंगे। और सॉफ्टवेयर्स यू मैनेज करके, जो सॉफ्टवेयर है हमारा, ये सारी सिस्टम जो इंस्टॉल किए उसको आप एक जगह से कंट्रोल कर सके, उसके लिए यू मैनेज करके एक सॉफ्टवेयर है, उसके बारे में बात करेंगे कि वो किस तरह से वर्क करता है, कैसे आप एक ही सॉफ्टवेयर में पूरा उसको मॉडिफिकेशन करके डैशबोर्ड पूरा देख सकते हैं और यूज कर सकते हैं। ये जो डोजिंग सिस्टम्स है उसे 40 किट कहते हैं। 40 किट 3G मॉडल है। यहाँ पे ऊपर जो लगा हुआ है वो है एनएमसी प्रो कंट्रोलर। तो कंट्रोलर क्या करता है कि पूरा जो भी आपका फंक्शन रहा, जो भी आपके वाल्व्स, आउटपुट्स, फील्ड में सेंसर्स, जो भी इंस्ट्रूमेंट लगे हैं उसका कंट्रोल यहाँ से कंट्रोलर्स के थ्रू होगा। कंट्रोलर में प्रोग्रामिंग होगा और उसके थ्रू आपका पूरा फील्ड्स के जो भी कंपोनेंट्स यूज हुए हैं उसका कंट्रोल होगा। ऊपर का पार्ट हो गया कंट्रोलर, नीचे जो आपको ये पूरी सिस्टम दिख रही है ये है पूरी डोजिंग सिस्टम्स। तो यहाँ पे नॉर्मली हम जब ड्रिप इरिगेशन करते हैं तो उसमें क्या करते हैं कि हेड यूनिट पे एक वेंचुरी यूज करते हैं। जब हमें इरिगेशन करना है तो आपकी लेटरल्स पाइप के थ्रू आप इरिगेशन करेंगे, और इरिगेशन के बाद जब फर्टिगेशन करना है तो फर्टिगेशन के लिए क्या होगा कि आपका जो हेड यूनिट है वहां पे आप एक वेंचुरी यूज करेंगे। तो वेंचुरी को यूज करने के लिए आपको क्या करना पड़ता है, उसका प्रेशर काटना पड़ता है, आपको उसको वेंचुरी को बंद करना पड़ता है। और आप अगर जब वेंचुरी यूज करेंगे तो आपको वेंचुरी को प्रेशर को बंद करके वेंचुरी के थ्रू फर्टिगेशन करना पड़ेगा। और इसमें हम क्या करेंगे, यहाँ पे आपको कोई भी मैनुअल पार्ट नहीं है, यहाँ पे आपको डिफरेंट डिफरेंट फ्री वेंचुरी दी हुई है। ये जो है यहाँ पे उसके ऊपर ये वेंचुरी है। तो आपकी जैसे जैसे अलग अलग फर्टिगेशन रहे उसको आप मेन्यू बना के एक डोजिंग टैंक जो रहेगी उसमें आप स्टोर कर सकते हैं। और उसके अकॉर्डिंग आपने जब उसको में प्रोग्राम करेंगे तो आपने जो भी प्रोग्राम किया है कि जो भी आपको फर्टिगेशन चलाना है, जैसे कि इसमें एनपीके रहा, माइक्रोन्यूट्रंस रहे, सल्फ्यूरिक एसिड रहा पीएच कंट्रोल करने के लिए, तो वो आप जब भी प्रोग्राम करेंगे आपकी रिक्वायर के अकॉर्डिंग सिर्फ वही टैंक में से और वही फर्टिगेशन अपने आप जाएगा। आपको उसमें प्रोग्राम कर देना है कि मुझे ये टैंक से इतना फर्टिगेशन करना है, इतना लीटर फर्टिगेशन करना है। तो उसके लिए आपको यहाँ पे ये जो है वो बूस्टर पंप है। बूस्टर पंप का वर्क क्या रहेगा कि जो भी आपको फर्टिगेशन करना है उसमें फर्टिलाइजर सक करना और उसको मेन लाइन में इंजेक्ट करना। मेन जो भी आपके फर्टिगेशन से सारी वेंचुरीज आपका यही अलग अलग क्रॉप के अलग अलग डोजिंग टैंक्स के अकॉर्डिंग वर्क करेगी आपने जो भी प्रोग्राम किया है। इसके बाद में यहाँ पे उसका यूनिट के साथ में लगा हुआ है ईसीपीएच कंट्रोलर। ईसीपीएच कंट्रोलर क्या करेगा, आपकी जो भी इरिगेशन हो रहा है उसमें आप फर्टिलाइजर कर रहे हो, फर्टिलाइजर का आपने प्लान कर दिया कि मुझे इस टैंक से कौन से फर्टिगेशन आपको फर्टिलाइज करने हैं, तो वो जो भी फर्टिगेशन हो रहा है उसका ईसी और पीएच कितना हो रहा है उसका मैनेजमेंट करेगी, आपका ईसी मेजरमेंट करेगी और पीएच कंट्रोल करेगी। अभी पहले हम देखेंगे कि नेटाजेट जो डोजिंग सिस्टम्स हैं और फर्टिकिट है, ये जो है ये फर्टिकिट है, ये नेटाजेट है। तो कौन सी सिस्टम्स कहाँ पे यूज होती है, तो नेटाजेट जो है वो टॉप मॉडल है। तो आपकी जो भी नर्सरीज रही, फिर ग्रीन हाउस हाइड्रोपोनिक्स ग्रीन हाउस रहे, ग्रीन हाउस सोइल बेस्ड रहे या फिर हाइड्रोपोनिक्स रहे, कोकोपीट मीडिया रही, सोइल विदाउट सोइल बेस्ड रहे, तो वहाँ पे ओपन फील्ड में हाइड्रोपोनिक्स में और ओपन फील्ड सोइल में सब जगह पे आप नेटाजेट जो मशीन है उसको यूज कर सकते हैं। फर्टिकिट स्पेशली क्या है कि सोइल बेस्ड जो मीडिया रहा उसके लिए फर्टिकिट यूज होती है। आप ओपन फील्ड रहा या ग्रीन हाउस रहा, जहाँ पे भी सोइल मीडिया रहा वहाँ पे फर्टिकिट यूज हो सकती है, ज्यादा प्रीफर फर्टिकिट करते हैं। और जो भी आपका सोइललेस मीडिया रहा वहाँ पे नेटाजेट यूज करते हैं। ये एक स्कीमेटिक डायग्राम है कि नॉर्मली आप इरिगेशन करते हैं तो क्या करते हैं, आपका पंप स्टार्ट हुआ, पानी लिफ्ट किया, फिर फिल्ट्रेशन में आया, पानी फिल्टर हुआ, उसके बाद आगे मेन लाइन में गया, मेन लाइन से सब मेन लाइन में गया और लेटरल के थ्रू इरिगेशन हुआ। अभी इरिगेशन प्लस फर्टिगेशन, फर्टिगेट का यूज करके अगर हमें इरिगेशन करना है तो हम क्या करते हैं, तो सबसे पहले हम क्या करेंगे, कंट्रोलर में प्रोग्रामिंग करेंगे। प्रोग्रामिंग के अकॉर्डिंग क्या होगा कि आपका इरिगेशन का जो पंप है, आपका वाटर पंप, वो स्टार्ट होगा। जो भी आपका वाटर सोर्स रहा, वॉल रहा या फिर संप रहा, वहां से वो क्या करेगा, पानी लेगा, पंप स्टार्ट होगा। उसके बाद फिल्ट्रेशन में आएगा, आपके डिफरेंट डिफरेंट सेंट फिल्टर, हाइड्रोसाइक्लोन, डिस्क फिल्टर, जो भी आपकी फिल्ट्रेशन सिस्टम्स होगी उसमें से फिल्टर होके पानी आगे जाएगा। फिर यहाँ पे 22 नंबर्स लिखा हुआ है, वो है आपका मेन वाल। मेन वाल में जाएगा। हमारे यहाँ पे जो भी सिस्टम्स रहती है वहाँ पे अगर अपनी मल्टी मेन लाइन रही, मतलब कि आपकी 3 से 4 अलग अलग मेन लाइन जा रही है, डिफरेंट डिफरेंट फील्ड है, तो जब उसमें प्रोग्रामिंग करेंगे तो मेन लाइन का मेन वाल जो है वो ओपन होगा, तो उसके बाद में ही वहाँ से आगे आप फर्टिगेशन कर सकते हैं, इरिगेशन कर सकते हैं। उसके लिए 22 नंबर जो है वो मेन वाल है। उसके बाद 19 नंबर जो है वो वाटर मीटर है। वाटर मीटर क्या करेगा कि आपकी क्वांटिटी कितनी जा रही है, आप टाइम बेस्ड इरिगेशन करते हैं या फिर वॉल्यूमेट्रिक करते हैं, तो आपकी क्वांटिटी कितनी जा रही है, आपको कितना इरिगेशन कर रहे हैं, उसके लिए वो वाटर मेजर करेगा कि कितना 1000 लीटर आपका पानी इरिगेट हो रहा है। उसके बाद यहाँ पे 4 टैंक्स लगी हुई है डिफरेंट डिफरेंट, उसमें अलग अलग फर्टिगेशन, आपको जो भी फर्टिलाइजर यूज करना है वो आप इसमें रख सकते हैं, NPK, माइक्रोन्यूट्रेंट या फिर पीएच कंट्रोल करने के लिए एसिड्स वगैरह। फिर ये जो ब्लू कलर के वो फिल्टर्स लगे हुए हैं, जो भी आपके फर्टिलाइजर हैं वो एकदम लिक्विड फॉर्म्स के थ्रू ही जाए वहाँ पे, उसके लिए सॉल्युबल फर्टिलाइजर जाए, उसके लिए वहाँ पे फिल्टर्स हैं। उसके बाद ये फिल्टर के थ्रू हमारे सारे फर्टिलाइजर्स जो है वो वेंचुरी में जाएंगे। फिर हमने जो भी प्रोग्राम किया है, जो भी वेंचुरी से फर्टिगेशन देना है, उसके अकॉर्डिंग ओनली वही टैंक में से जो है अपना बूस्टर पंप, जो फर्टी किट में पंप आता है, डोजिंग पंप, बूस्टर पंप, वो वही फर्टिगेशन पंप जो है वो उसको सक करेगा, फर्टिलाइजर को सक करके फिर मेन लाइन में इंजेक्ट करेगा। तो आपने जो भी इरिगेशन के साथ में जो भी फर्टिगेशन के प्रोग्राम किए हुए टैंक ए, बी, सी और डी में से, तो वही टैंक में से वो फर्टिलाइजर लेगा और आपकी मेन लाइन में इंजेक्ट करेगा। अभी नॉर्मली क्या होता है कि हम जब वेंचुरी से इरिगेशन करते हैं तो पहले वेंचुरी का इन होता है, बाद में आउट होता है, और बीच में जो वेंचुरी सक करेगी उसके बाद डायरेक्ट आउट में से वो आपकी फील्ड में चला जाएगा। लेकिन यहाँ पे जो ये प्रोसेस है वो रिवर्स है। यहाँ पे वाटर मीटर के बाद में जो 16 नंबर्स है वो पहले आउट लगा हुआ है और बाद में इन है। तो ये क्या करेगा, यहाँ से आपका जो प्लेन वाटर जा रहा है वो प्लेन वाटर लेगा, फिर यहाँ से आपका जो भी फर्टिगेशन करना है वो फर्टिगेशन लेगा, और उसके बाद में वहाँ पे ECPH सैंपल चेक करके फिर वो यहाँ पे इंजेक्ट करेगा। फिर क्या होगा, ये तो रिवर्स प्रोसेस हो गई कि पहले इन है बाद में आउट है। तो यहाँ से ये आउट में से वो आपका फर्टिलाइजर वाला पानी आ गया, जो आपका नॉर्मल वाटर के साथ फर्टिलाइजर मिक्स हो गया। फिर यहाँ से फिर से वो यहाँ से वही पानी लेगा, क्योंकि आपको इरिगेशन तो आप ज्यादा करेंगे, वाटर क्वांटिटी आपकी बहुत ज्यादा होगी और फर्टिलाइजर जो क्वांटिटी है वो कम होगी। तो यहाँ से फिर वो वाटर लेगा और उसमें जो भी आपके माइक्रोन्यूट्रिएंट्स और फर्टिलाइजर्स है उसका EC और pH मेजर करेगा, और EC और pH मेजर करके उसके अकॉर्डिंग अगर उसमें ज्यादा फर्टिगेशन की रिक्वायरमेंट है तो वो करेगा, अगर EC कम करना है तो ज्यादा पानी ऐड करना है तो पानी ऐड करेगा, और उसके बाद में फिर वो वहां से यहाँ पे आएगा। और ये जो है ये अपना मेन वाल्व है एक, यहाँ पे से फर्टिगेशन चेक करेगा, और यहाँ पे एक NRV भी है, एक NRV भी यूज होता है कि यहाँ पे आपका जो भी इरिगेशन फर्टिलाइजर आया है वो रिटर्न ना जाए, उसके लिए नॉन रिटर्न वाल्व लगेगा। और उसके बाद यहाँ पे ये डिफरेंट सोलेनोइड वाल्व है, उसके थ्रू आपका जो भी है वो फर्टिगेशन होगा। अभी इसमें जो है डिफरेंट वेंचुरीज रही, अगर आपने ड्रिप इरिगेशन के साथ मैन्युअल वेंचुरी लगाते हैं तो आपको हर बार जब भी जो भी फर्टिगेशन देना है उसको बनाना पड़ेगा, उसको फर्टिलाइजर रेडी करके ड्रम में लाके फिर लिफ्ट करवाना पड़ेगा। इसमें क्या है कि आप फर्टिलाइजर एक साथ बना के टैंक के अकॉर्डिंग रख सकते हैं, जो भी आपकी फर्टिगेशन रिक्वायरमेंट रही, फिर आपने जो भी प्रोग्राम किया सिर्फ वही फर्टिगेशन वो उस प्लॉट में इरिगेशन और फर्टिगेशन करेगा। तो ये जो 4 डिफरेंट फर्टिलाइजर की वेंचुरी है तो उसकी कैपेसिटी क्या है कि 50 लीटर से लेके 400 लीटर तक ये एट अ टाइम 400 लीटर पर आवर फर्टिलाइजर दे सकता है। 4 वेंचुरी रही तो हर एक की कैपेसिटी 400 लीटर पर आवर्स की है। फिर आप एक चैनल चलाएंगे तो भी 400 लीटर पर आवर जाएगा और चारों चैनल चलाएंगे तो भी हर एक चैनल में से 400 लीटर पर आवर्स की कैपेसिटी के अकॉर्डिंग वो आपका फर्टिलाइजर इंजेक्ट करेगा मेन लाइन में। इसमें 4 वेंचुरी में ये फर्टिगेशन की वेंचुरीज आती है ये मॉडल में। फिर बाद में 6 वेंचुरीज तक आप उसको एक्सपांड कर सकते हैं। जैसे ही आपने 6 वेंचुरी को एक्सपांड किया तो उसका जो पंप है उसका HP बढ़ जाएंगे, और साथ ही में वेंचुरी की कैपेसिटी भी बढ़ी आएगी, क्योंकि आपकी वेंचुरी बढ़ेगी तो आपके डिफरेंट फर्टिलाइजर बढ़ेंगे, आपका बूस्टर पंप भी बड़ा होगा, आपका एरिया भी चेंज होगा, तो उसके अकॉर्डिंग 1000 लीटर तक की चैनल्स आएगी। उसमें जो है पर चैनल पर वेंचुरी की कैपेसिटी ये 1000 लीटर पर आवर्स की रहेगी। अभी ये जो फर्टिगेशन सिस्टम्स है उसमें ये क्या करता है कि डायरेक्ट आपका जो फर्टिगेशन है बूस्टर पंप के थ्रू आपका फर्टिलाइजर आता है टैंक से, और डायरेक्ट ECPH चेक होके मेन लाइन में चेक करता है। तो ये क्या हुआ कि हमारी बाईपास सिस्टम हुई कि यहाँ पे फर्टिगेशन आया, हैंडल किया, सक किया, उसका ECPH मेजर किया और डायरेक्ट मेन लाइन में इंजेक्ट कर दिया। तो अंदर मिक्स होने के लिए कोई ऐसी जगह नहीं है कि जहाँ पे ये पूरा मिक्स कर सके और ये कर सके। उसके लिए ये जो सिस्टम्स है उसको हम बाईपास बोलते हैं, बाईपास सिस्टम्स। नेटाजेट सिस्टम जो है उसको हम मेन इनलाइन सिस्टम्स बोलते हैं। क्यों? क्योंकि वहां पे एक हाइड्रोमिक्स चैम्बर बनी हुई है। हाइड्रोमिक्स चैम्बर में क्या होगा कि जो भी आपका इरिगेशन का प्लेन वाटर आएगा, इरिगेशन कर रहे हैं, और जो भी आपका फर्टिगेशन उसमें ऐड होगा, उसके बाद वो हाइड्रोमिक्स चैम्बर में उसको प्रॉपरली मिक्स करेगा। उसमें पाथ दिए हुए हैं और स्टैंड लगा हुआ है, उसके अकॉर्डिंग ये क्या करेगा, मिक्सिंग चैम्बर में पूरा मिक्स करेगा, और वहां पे जो आपकी ECPH की एक्यूरेसी है वो इससे 10 से 15% ज्यादा मिलेगी आपको। अभी इसके बारे में बात करें तो उसको 8 वेंचुरी तक फर्टिकिट को हम बढ़ा सकते हैं। फर्टिकिट 3G 4 बेसिक्स में 4 वेंचुरी आती है, उसको 8 तक आप एक्सपांड कर सकते हैं। और 4 चैनल जो रहेगी 4 वेंचुरी, उसकी जो कैपेसिटी है वो 50 लीटर से 400 लीटर पर आवर्स की है। और जो बाद में आप एक्सपांड करेंगे उसको 8 तक, तो उसकी जो कैपेसिटी होगी वो 50 लीटर से लेके 1000 लीटर पर आवर्स की रहेगी। कॉस्ट एफिशिएंट सॉल्यूशन है। सॉइल बेस्ड जो भी मीडिया है, चाहे ओपन फील्ड रहा या ग्रीन हाउस, वहां पे किसी में भी आप यूज कर सकते हैं। ये उसका पाथ दिया हुआ है। यहाँ से क्या करेगा कि आपकी ये जो मेन लाइन है वो जा रही है, यहाँ पे आपकी डिफरेंट डिफरेंट टैंक लगी होगी, तो टैंक से आपका फर्टिगेशन इन होगा, यहाँ से आउट होगा, और यहाँ से मेन लाइन में इंजेक्ट होगा। ये जो फर्टिकिट है वो 2.5 kg से 6.5 kg तक अगर आपका प्रेशर है मेन लाइन में, वहां तक आप यूज कर सकते हो। अगर आपका उससे ज्यादा प्रेशर है, कहीं पे गोल्फ में यूज होती है, तो वहां पे क्या रहता है कि लैंडस्केप में कई जगह यूज होती है, तो वहां पे उसका जो मेन लाइन का प्रेशर है वो 7 kg 8 kg तक रह जाता है। तो आपका जब भी प्रेशर बढ़े तो उसके अकॉर्डिंग आप अलग अलग डिफरेंट डिफरेंट मॉडल यूज कर सकते हैं। और जब जैसे मॉडल बढ़ेंगे उसके अकॉर्डिंग उसका बूस्टर पंप की साइज बढ़ेगी, वेंचुरी की कैपेसिटी बड़ी हो सकती है। ये जो है ये कुछ स्कीमेटिक्स डायग्राम है कि किस तरह से उसके कनेक्शन कर रहे हैं। यहाँ पे कंट्रोलर लगा हुआ है, यहाँ पे ECPH का कंट्रोल है, यहाँ पे आपकी जो भी चैनल्स रहेगी वहां पे भी एक, जिस तरह से हम फील्ड में सोलेनोइड वाल्व यूज करते हैं कि कौन सा वाल्व में कौन से एरिया में इरिगेशन करना है, वैसे ही यहाँ पे जो भी आपकी 4 वेंचुरी रहेगी उसके ऊपर एक बूस्टर के लिए आपका जो भी डोजिंग टैंक है वो सिलेक्ट करने के लिए एक बकारा वाल आएगा। तो हर एक में से उसमें आपको प्लान कर दिया, उसमें आपने प्रोग्राम किया कि कौन से टाइम पे कौन से प्लॉट में कौन सा फर्टिगेशन करना है। तो वो सिलेक्ट करने के बाद यहाँ पे जो है आपकी टैंक से फर्टिगेशन सक करके यहाँ पे एक बकारा वाल आएगा, उसके थ्रू बकारा वाल जो है आपका वो ओपन होगा, और वहां से आपका सिर्फ जो भी आपने प्रोग्राम किया है वही फर्टिलाइजर वो सक करके मेन लाइन में इंजेक्ट करेगा। अभी बात करते हैं नेटाजेट की। तो नेटाजेट में 3 टाइप्स के मॉडल हैं, डिफरेंट। लेफ्ट साइड में जो सबसे पहला दिख रहा है वो नेटाजेट का रेगुलर मॉडल्स है। दूसरा जो मॉडल्स आपको बीच में दिख रहा है वो इनलाइंस मॉडल्स है। और ये जो है ये छोटे फील्ड रहे जहाँ पे आपका स्मॉल ग्रीन हाउसेस रहे, 1 एकड़ 2 एकड़, और जहाँ पे आपकी इरिगेशन रिक्वायरमेंट कम रही वहाँ पे जो है ये स्मॉल मॉडल्स यूज होता है। इसकी जो कैपेसिटी है वो 5 मीटर क्यूब से 20 मीटर क्यूब, मतलब आप जो इरिगेशन कर रहे हैं उसका जो वाटर है उसकी मैक्सिमम क्वांटिटी 20,000 लीटर प्रति हवर्स पर हवर्स, उससे ज्यादा नहीं होनी चाहिए। मतलब जो भी स्मॉल फील्ड्स है वहाँ पे ये सिस्टम जो है वो एक्यूरेट काम कर सकती है। सबसे पहली जो सिस्टम्स है इनलाइन सिस्टम्स, रेगुलर सिस्टम्स, वो उसका जो फ्लो है वो 20 मीटर क्यूब, मतलब कि मिनिमम आपका फ्लो 20,000 लीटर से 120 मीटर क्यूब तक हो, वहाँ पे ये सिस्टम्स प्रॉपरली वर्क कर सकती है। तीसरी जो सिस्टम है हाई फ्लो, जहाँ पे आपका फ्लो जो है वो 120 मीटर क्यूब से 400 मीटर क्यूब हो, वहाँ तक ये जो नेटाजेट है वो सिस्टम्स काम कर सकती हैं। ये हाई फ्लो नेटाजेट है। अब जैसे ही आपका फ्लो बढ़ेगा उसके अकॉर्डिंग क्या होगा कि आपकी फर्टिगेशन की रिक्वायरमेंट भी बढ़ेगी। तो जो भी हमारा नेटाजेट रेगुलर मॉडल्स है और नेटाजेट लो फ्लो मॉडल्स हैं, उसमें वेंचुरी की जो कैपेसिटी रहेगी वो 400 लीटर की रहेगी। इसमें डिफरेंट डिफरेंट 5 वेंचुरी आ रही है, आप देख सकते हैं इसमें दिख रहा है आपको 5 वेंचुरी है। तो हर एक वेंचुरी की कैपेसिटी 400 लीटर पर आवर्स की होगी रेगुलर मॉडल्स में और लो लो मॉडल्स में। फिर जो नेटाजेट हाई फ्लो है उसमें हर एक वेंचुरी की कैपेसिटी 1000 लीटर्स पर आवर की रहेगी, मतलब कि आपके जो भी टैंक्स है उसमें से 1000 लीटर पर आवर। और 5 वेंचुरी अगर आप एट टाइम चलाते हैं आपको फर्टिगेशन के लिए डिफरेंट डिफरेंट, तो टोटल जो आपकी फ्लो होगा वो 1 आवर्स में 1 कलाक में वो 5000 लीटर फर्टिगेशन जो है वो सब करके इंजेक्ट कर सकता है। 5000 लीटर पर आवर टोटल कैपेसिटी। यहाँ पे ये उसके बूस्टर पंप लगे हुए हैं, अगर रेगुलर है तो 3 HP का पंप है, इसमें भी 3 HP का पंप है। यहाँ पे जो आपका हाई फ्लो मॉडल है उसमें 7.5 HP का पंप लगा हुआ है। तो आपके जो भी मॉडल्स है जैसे आपकी कैपेसिटी बढ़ेगी उसके अकॉर्डिंग आपके जो पंप्स है उसके HP बढ़ेंगे। तो हमें फर्टी किट देखी, नेटाजेट देखा, तो फर्टी किट का यूज क्या है कि हम ओपन फील्ड में कर सकते हैं डोजिंग सिस्टम्स के लिए। फर्टी किट और नेटाजेट अपनी डोजिंग सिस्टम्स हैं। फर्टी किट का यूज ओपन फील्ड या फिर ग्रीन हाउस में जहाँ पे भी सोइल मीडिया है वहां पे यूज कर सकते हैं। जहाँ पे ग्रीन हाउस में क्लाइमेट कंट्रोल है प्लस जहाँ पे सोइल मीडिया नहीं है, कोकोपीट है, हाइड्रोपोनिक्स है, वहाँ पे जो है वो ज्यादातर नेटाजेट प्रीफर होता है। नेटाजेट जो है वो टॉप मॉडल है, तो जहाँ पे आप फर्टी किट यूज कर सकते हैं वहीं पे तो वहाँ पे तो कर ही सकते हैं, लेकिन मेन जो है ये आपके सोइललेस मीडिया जहाँ पे भी रहा वहाँ पे सबसे ज्यादा प्रीफर होता है। अभी ये जो नेटाजेट है मैंने जिस तरह से बताया कि फर्टी किट जो है वो आपकी बाईपास सिस्टम से, मतलब क्या करेगा, फर्टिलाइजर लेगा और डायरेक्ट मेन लाइन में इंजेक्ट कर देगा। बूस्टर पंप जो है वो बूस्ट करके आपको डायरेक्ट मेन लाइन में इंजेक्ट कर देगा। नेटाजेट में क्या है कि हाइड्रोमिक्स चैम्बर आती है अलग से। तो हाइड्रोमिक्स चैम्बर क्या करेगी कि आपका जो भी फर्टिगेशन इन हुआ है, जो भी फर्टिलाइजर्स आपका नेटाजेट में आया वेंचुरी के थ्रू, उसको यहाँ पे पूरा प्रॉपरली वो मिक्स करेगी। मिक्स करने के बाद उसका ECPH चेक करेगी। ECPH कंट्रोल करने के बाद में पूरा फर्टिगेशन का, उसके बाद में ये आपकी मेन लाइन में इंजेक्ट करेगी। तो ये क्या हुआ कि इनलाइन सिस्टम हो गई। और फर्टिकिट जो है वो आपकी बाईपास सिस्टम हुई, वो डायरेक्ट मेन लाइन में आपका फर्टिगेशन इंजेक्ट करती है। ये क्या करेगी, आपका जो फर्टिगेशन है उसको हाइड्रोमिक्स चैम्बर में प्रॉपर मिक्सिंग करेगी। वहाँ पे जो है डिफरेंट ऐसे पाथ दिए हुए ताकि फर्टिगेशन जो है वो प्रॉपरली मिक्स हो और उसके बाद में आगे जाए। यहाँ पे आपकी 5 अलग अलग डोजिंग चैनल्स आती है। फर्टी किट में 4 आती है, उसको आप एक्सपांड करके 8 तक कर सकते हैं। यहाँ पे ये जो दिखाया हुआ है नेटाजेट मॉडल, यहाँ पे ये जो चैम्बर है उसकी मिक्सिंग हाइड्रोमिक्स चैम्बर दी हुई है। हाइड्रोमिक्स चैम्बर में ये मिक्सिंग होके आपका फर्टिगेशन फिर मेन लाइन में इंजेक्ट होगा। ये जो हमारा मॉडल है वो है नेटाजेट इनलाइन मॉडल्स। इनलाइन मतलब कि जहाँ पे रिक्वायरमेंट 5 मीटर क्यूब के फ्लो से 20 मीटर क्यूब फ्लो तक है, वहां पे नेटाजेट इनलाइन मॉडल यूज होता है। पीएच कंट्रोल करने के लिए आप एसिड इसमें यूज कर सकते हैं। प्रोवाइड फास्ट एंड एक्यूरेट फर्टिलाइजर एंड एसिड कंट्रोल, कन्वर्ट्स प्रिसाइज पल्सिस फर्टिगेशन इनटू अ यूनिफॉर्म सॉल्यूशंस। यहाँ पे आपकी मेन लाइन से यहाँ पे ये फर्टिगेशन लेगा, ECPH करेक्ट करेगा और फिर बाद में मेन लाइन में इंजेक्ट करेगा। हाइड्रोमिक्स चैम्बर के साथ में ये आती है। इनलाइन मॉडल से सबसे जो लो फ्लो वाला जो मॉडल है वो ये है। यहाँ पे उसका आपको टिपिकल इंस्टॉलेशन किस तरह से करते हैं उसका एक व्यू दिया हुआ है। ये जो आपका यहाँ पे वाटर सोर्स रहा, वहां से उसके बाद में वाटर सोर्स रहा, उसके बाद में इसका इरिगेशन पंप रहा, उसके बाद में फिल्टर है तो पंप ऑन होगा, फिल्ट्रेशन होगा, उसके बाद उसका मेन वाल है। तो जब मेन वाल ओपन होगा तभी आपका पानी जो है फील्ड में आगे जाएगा। उसके बाद यहाँ पे उसका वाटर मीटर है, तो आपका पानी कितना जा रहा है उसको गिनने के लिए आपको मीटर क्यूब वॉल्यूमेट्रिक इरिगेशन करने के लिए वहाँ पे वाटर मीटर यूज कर सकते हैं। फिर यहाँ पे ये आपको 3 डिफरेंट डोजिंग टैंक्स दिखाए हुए हैं। जो भी आपका प्रोग्राम रहा उसके अकॉर्डिंग ये डोजिंग चैनल डोजिंग टैंक में से फर्टिलाइजर लेगा इनलाइन है तो यहाँ पे ये पंप है और यहाँ पे ये इनलाइन मिक्सिंग करके फिर आपको जो है मेन लाइन में इंजेक्ट करेगा। इसको साथ में हम कितने वाल्व्स चला सकते हैं, अगर आपका क्वेश्चन रहेगा कि छोटा फील्ड है बड़ा फील्ड है तो कहाँ पे ये यूज करना चाहिए, कहाँ पे रिलायबल है और कौन से उसके साथ में कंट्रोलर्स आते हैं। जैसे मैंने बात की कि कंट्रोलर्स जो है वो बेसिक है, सबसे पहले हमें कंट्रोलर्स की रिक्वायरमेंट रहेगी। तो उसके साथ में जो कंट्रोलर्स आते हैं वो है एनएमसी प्रो। उसमें आप 64 आउटपुट्स मतलब सोलेनोइड्स, वाल्व्स, डोजिंग चैनल 64 तक ओपन कर सकते हैं, उसमें यूज कर सकते हैं। जो भी अपने सोलेनोइड्स वाल्व्स रहेंगे वो जहाँ पे भी वायरिंग सिस्टम है वहाँ पे एसी वाल्व्स यूज होते हैं जिसका ऑपरेशन है 24 वोल्ट एसी पे ओपन होते हैं। उसका जो वोल्टेज है वो 24 वोल्ट एसी पे आपके सोलेनोइड्स वाल्व्स ओपन होंगे। और जहाँ पे आपकी वायरलेस सिस्टम है वहाँ पे क्या होगा कि वहाँ पे एक रेडियो टर्मिनल यूनिट लगेगा। मतलब आपका जो भी कंट्रोलर लगा हुआ है वो सबसे पहले कमांड देगा रेडियो टर्मिनल यूनिट्स को। रेडियो टर्मिनल यूनिट्स जहाँ पे लगा हुआ है उसके पास में आपके सोलेनोइड्स वाल्व होंगे। तो रेडियो टर्मिनल से सिग्नल, जैसे ही कंट्रोलर से सिग्नल रेडियो टर्मिनल यूनिट में आया तो वहां से आपके वाल्व्स को जाएगा। तो वहां पे जो है वाल्व्स ओपन होने के लिए वहां पे सप्लाई तो है नहीं, तो जो भी आपके आरटीयूज लगे हुए उसमें बैटरी रहती है तो बैटरी के थ्रू ओपन होगा। तो उसके लिए हम वहां पे डीसी लैच कॉइल लगाएंगे। जो एसी वाल्व से अपने जो भी वायरिंग के वाले वाल्व से वो उसके ऑपरेशन 24 वोल्ट एसी पे होगा और ये जो है अपने आरटीयू सिस्टम वायरलेस वो जो है वहां पे डीसी लैच लगेगी। इसमें 8 डिजिटल इनपुट्स मतलब कि जो वाटर मीटर से फर्टिलाइजर्स मीटर, जिस तरह से वाटर मीटर आते हैं जिसमें आप वॉल्यूमेट्रिक इरिगेशन करने के लिए जिस तरह से यूज कर सकते हैं वैसे ही फर्टिगेशन करने के लिए फर्टिलाइजर्स मीटर्स आते हैं तो वो आप यूज कर सकते हो। और 11 एनालॉग इनपुट्स। एनालॉग इनपुट्स मतलब क्या होते हैं कि जो भी आपके सेंसर्स रहेंगे जैसे कि ईसीपीएच सेंसर हो गया, फिर बाद में आपका मॉइस्चर सेंसर हो गया, तो वो सारे ही आपके आउटपुट्स जो है वो एनालॉग में आएंगे। तो 11 एनालॉग इनपुट्स आते हैं उसमें, तो आप डिफरेंट 11 टाइप्स के जो सेंसर्स हैं उसको कनेक्ट कर सकते हैं, जो भी एनालॉग टाइप के सेंसर रहे। और डिजिटल इनपुट्स आते हैं 8, तो उसमें आप वाटर मीटर और जिस तरह से वाटर मीटर है वैसे ही फर्टिलाइजर देने के लिए फर्टिलाइजर काउंटर या फर्टिलाइजर मीटर कनेक्ट कर सकते हैं। इसको जो है आप एक्सपांड कर सकते हैं, मतलब कि अगर मेरे फील्ड में ज्यादा सेंसर्स हैं, ज्यादा मॉइस्चर सेंसर्स लगे हुए हैं या फिर मुझे 2 ईसीपीएच सेंसर्स यूज करने हैं तो इसमें लिमिटेशन है 11 की। अगर 11 से मेरे सेंसर बढ़ गए तो क्या है कि मैं उसको 22 नंबर्स तक एक्सपांड कर सकता हूँ। मतलब कि सेम कंट्रोलर सेम यूनिट्स में मैं उसमें एक कार्ड ऐड कर सकता हूँ, एक सर्किट ऐड करके उसको 22 इनपुट्स तक एक्सपांड कर सकता हूँ। वैसे ही डिजिटल इनपुट्स जो है वो 32 तक एक्सपांड कर सकता हूँ। ईसीपीएच जो है नेटाजेट में वो सिंगल मेजरमेंट मतलब वन टाइम ईसीपीएच जो है आपका मेजर करके बाद में मेन लाइन में इंजेक्ट करेगा। अगर आपको ज्यादा एक्यूरेसी चाहिए, हाइड्रोपोनिक्स रहे या फिर आपका कोकोपीट मीडिया रहा जहाँ पे आपको एक्यूरेसी जो है नॉर्मल से ज्यादा लगे चाहिए तो वहां पे आप ड्यूअल मेजरमेंट्स मतलब ईसी और पीएच 2 बार वो मेजर करेगा, एक एंटर हुआ तब और एक बाद में जब आउट होता है तब, तो 2 बार मेजर करके ज्यादा एक्यूरेसी के साथ आपको अगर वो डिलीवर करना है तो ड्यूअल मेजरमेंट्स, ड्यूअल आप ईसीपीएच यूज कर सकते हैं। नेटाजेट बाईपास, जो नेटाजेट रेगुलर है उसका जो फ्लो है वो 20 मीटर क्यूब से 120 मीटर क्यूब, सॉरी नेटाजेट इनलाइन का जो फ्लो है वो 0.5 मीटर, सॉरी यहाँ पे एक मिस्टेक है, 5 मीटर क्यूब से लेके 20 मीटर क्यूब आपका जो फ्लो है वहां तक यूज कर सकते हैं नेटाजेट इनलाइन। डोजिंग चैनल्स जो है वो 5 डोजिंग चैनल्स रहेगी जो आपकी 400 लीटर पर आवर्स की कैपेसिटी के साथ में रहेगी। और प्रेशर जो है सिस्टम प्रेशर वो 3 kg से 6.2 बार 6.2 kg तक आप जो भी प्रेशर रहा तो वहां तक नेटाजेट इनलाइन मॉडल्स यूज कर सकते हैं। अब बाद में जो है नेटाजेट बाईपास, ये सिस्टम क्या है कि जो आपका जब आपका फ्लो बढ़ेगा 20 मीटर क्यूब से 20 मीटर क्यूब से जब आपका फ्लो बढ़ेगा और 120 मीटर क्यूब है वहां तक आप नेटाजेट बाईपास यूज कर सकते हैं। नेटाजेट बाईपास का भी फंक्शन जो है ईसीपीएच का वो सेम ही है, लेकिन फ्लो बढ़ेगा तो उसके अकॉर्डिंग आप कर सकते हैं। इसमें भी ड्यूअल ईसीपीएच मेजरमेंट्स हैं। अगर आपको एक्यूरेसी इरिगेशन करना है तो ड्यूअल ईसीपीएच है। कंट्रोलर मिक्सिंग चैम्बर्स, हाइड्रोमिक्स चैम्बर जो आपको एक्यूरेसी के लिए चाहिए वो भी इसमें है। इसके साथ में और उसको जो है सेम एक्सपांड कर सकते हैं जिस तरह से हमने नेटाजेट इनलाइन में बात की वैसे ही। उसके बाद में जो मॉडल है वो है नेटाजेट हाई फ्लो। हाई फ्लो मतलब कि आपका जब भी फ्लो 120 मीटर क्यूब से बढ़ेगा तब आप नेटाजेट हाई फ्लो यूज कर सकते हैं। जो भी बड़े प्लॉट्स रहे, बड़े फील्ड रहे, वहाँ पे नेटाजेट हाई फ्लो यूज होता है। और इसमें जो है वेंचुरी की कैपेसिटी आपकी 1000 लीटर्स पर हावर की रहेगी। तो पता चला है कि आपकी जो है उसका कुछ स्कीमेटिक डायग्राम है। ये आपका वाटर सोर्स है, उसके बाद इरिगेशन पंप लगा हुआ है, यहाँ पे आपके फिल्टर सिस्टम है, यहाँ पे आपका मेन वाल है, वाटर मीटर है, यहाँ से आपकी डोजिंग चैनल्स लगी हुई है जिसके थ्रू ये अपनी जो अकॉर्डिंग फर्टिलाइजर सक करेगा। बाद में जो है यहाँ पे हाइड्रोमिक्स चैम्बर में ईसीपीएच के साथ जो भी आपने डिजायरेबल ईसीपीएच डाला है इसमें कंट्रोलर में, आप इसकी वैल्यू को कर सकते हैं सेव। तो मुझे जो है 6.5 पीएच से ही हमारा जो भी फर्टिगेशन है वो होना चाहिए। तो 6.5 पीएच से अगर आपका पीएच बढ़ गया तो आप पीएच कंट्रोल करने के लिए हमें एसिड की रिक्वायरमेंट, आपका जो है पीएच करेक्ट करके 6.5 जो आपकी डिजायरेबल वैल्यू है वो 6.5 रख के बाद में ही वो आगे आपकी मेन लाइन में इंजेक्ट करेगा, आउट करेगा, आउट में से आपका फ्लो निकलेगा। ये जो है यहाँ पे ये आपके बकारा वाल्व्स हैं, ये वेंचुरी है। वेंचुरी पे के ऊपर जो ऑरेंज कलर्स के राउंड्स वाले जो नॉब लगे हुए हैं उसके थ्रू आप फर्टिगेशन को कंट्रोल कर सकते हैं। ये जो अपनी वेंचुरी रही उसकी कैपेसिटी या 400 लीटर्स की रहेगी या 1000 लीटर्स की रहेगी पर आवर। तो अगर आपको 400 लीटर फर्टिगेशन नहीं देना है तो उसको आप जो है नॉब के थ्रू भी कंट्रोल कर सकते हैं। उसके बाद में जो वहाँ पे ब्लैक कलर के लगे हुए ये है उसके बकारा वाल क्लोज करने के लिए, इरिगेशन करने के लिए। सेम वैसे ही आपने डोजिंग टैंक लगा दिया, इसमें प्रोग्राम कर दिया कि मुझे पर्टिकुलरली ए टैंक से और सी टैंक से ही फर्टिगेशन होना है तो उसी के वाल्व्स जाएगा। तो ये जो है 5 वेंचुरीज इसमें इनबिल्ट आती है। अगर नेटाजेट इनलाइन और नेटाजेट रेगुलर रहा तो उसकी जो वेंचुरी है वो 400 लीटर्स और ऊपर रहा तो 100 लीटर पर आवर की कैपेसिटी है। इसमें भी आप 64 आउटपुट्स 24 वोल्ट एसी वाले चला सकते हैं। उसको एक्सपांड करके मुझे अगर बड़ा फील्ड इनपुट्स 11 एनालॉग इनपुट्स रहते हैं उसको भी मैं एक्सपांड कर सकता हूँ। ईसीपीएच अगर मुझे सिंगल मेजरमेंट करना है तो सिंगल मेजरमेंट, और अगर मुझे ज्यादा एक्यूरेसी, फ्लो रेट जो है वो है 120 मीटर क्यूब से 400 मीटर क्यूब तक, और सिस्टम प्रेशर जो है 2.8 बार से 6.2 बार तक। अभी मेनली हमारा कंट्रोलर हुआ, कंट्रोलर के बाद हमने बात की फर्टिगेशन सिस्टम्स की। तो हमने सबसे पहले देखा फर्टिकिट, बाद में देखा नेटाजेट, 4 वेंचुरी 5 वेंचुरी और 8 वेंचुरीज की बात की। तो वैसे ही 41 में जो है सिंगल वेंचुरी आती है, मतलब जहाँ पे आपको डिफरेंट टाइप के ज्यादा फर्टिगेशन नहीं करने हैं वहां पे आप जो है 41 सिस्टम का यूज कर सकते हैं। उसके साथ में ईसीपीएच कंट्रोलर नहीं आता, मतलब ओनली डोजिंग करना है,
नहीं जमीन है
फर्टिगेशन करना है। वहां पे जो है आप वहां पे जो है आप 41 सिस्टम्स का यूज कर सकते हैं जहाँ पे आपको मल्टीपल डोजिंग्स नहीं है, वहां पे सिंगल चैनल सिंगल टैंक के साथ में आपको यूज करना है वहां पे। तो ये 3 जो है डोजिंग सिस्टम्स हो गई, 41, फर्टिकिट और नेटाजेट। 41 जहाँ पे छोटे फील्ड है वहां पे यूज होगा, फर्टिकिट जो है वहां पे आपके जो फील्ड है उसका फ्लो 20 मीटर क्यूब से 120 मीटर क्यूब होगा। और जहाँ पे आपको ECPH कंट्रोल करना है, ग्रीन हाउस रहे सोइल में, सोइल बेस, या फिर ओपन फील्ड रहा, वहाँ पे 40 किट यूज करेंगे। और जहाँ पे आपकी ग्रीन हाउस रहे सोइल मीडिया जहाँ पे नहीं है, कोकोपीट है या सोइल मीडिया नहीं है, वहाँ पे जहाँ पे ज़्यादा आपको ECPH की हाई एक्यूरेसी चाहिए, वहाँ पे जो है नेटाजेट के जो मॉडल्स हैं वो यूज करेंगे। नेटाजेट के जो मॉडल्स है वो फ्लो के अकॉर्डिंग है। आपका जो मेन लाइन, आपका इरिगेशन कितना हो रहा है उसका जो फ्लो है उसके अकॉर्डिंग मॉडल। ECPH ड्यूअल मेजरमेंट्स आता है, 2 ECPH आप कंट्रोल कर सकते हैं, इरिगेशन फर्टिगेशन सब कुछ सेम रहता है। अभी इरिगेशन और फर्टिगेशन के बाद में आगे जो बात करेंगे वो है हम सेंसर्स। तो कौन से सेंसर कहाँ यूज होते हैं सेंसर्स? तो ओपन फील्ड जहाँ पे रहा वहाँ पे आपका मॉइस्चर सेंसर्स यूज कर सकते हैं, फिर वेदर स्टेशन यूज कर सकते हैं। फिर जहाँ पे अगर आपके ग्रीन हाउस रहे, नर्सरीज रही, जहाँ पे ग्रीन हाउस में आपको क्लाइमेट कंट्रोल करना है तो वहाँ पे डिफरेंट डिफरेंट टाइप्स के सेंसर्स रहते हैं। टेम्परेचर सेंसर्स हैं, अभी ग्रीन हाउस रहा तो ह्यूमिडिटी को कंट्रोल करना पड़ेगा तो ह्यूमिडिटी सेंसर्स है। फिर हीटर्स है, जहाँ पे हिमाचल प्रदेश हो गया, कश्मीर हो गया, जहाँ पे ठंडी ज्यादा है वहाँ पे जो है हीटर्स का भी यूज करते हैं। अपने यहाँ पे कूलिंग करने के लिए कूलिंग पैड, कूलिंग फैन और पेड का यूज करना है, कूलिंग फैन का यूज करना है। वो कौन से टेम्परेचर पे ऑटोमेटिक ओपन क्लोज होने चाहिए, शेड नेट जो है, पार लैंप है, फिर बूम इरिगेशन करना है। तो ये सारे जो सेंसर्स हैं उसको कैसे कनेक्ट कर सकते हैं, कौन से सेंसर का कहाँ पे यूज करना है, और वो सेंसर्स अपने जो नेटाफेम के कंट्रोलर्स हैं उसके साथ किस तरह से यूज कर सकते हैं उसके बारे में बात करेंगे। तो सेंसर जो है ECPH, सबसे पहले ECPH सेंसर जो है उसको हम कर सकते हैं। टेम्परेचर ह्यूमिडिटी सेंसर्स हैं उसको कनेक्ट कर सकते हैं। सोइल मॉइस्चर जो है उसको कनेक्ट कर सकते हैं, और मॉइस्चर बेस्ड इरिगेशन करने के लिए सॉइल मॉइस्चर सेंसर्स हैं। CO2 के बाद में जो है वेदर मॉनिटरिंग स्टेशन, जो वेदर स्टेशन है, सोलर रेडिएशन है, उसमें विंड स्पीड, विंड डायरेक्शन, रेन सेंसर्स है उसके लिए। और आखिरी में जो है एक ड्रेन ECPH, मीन्स आपका जो भी ड्रेन ECPH सेंसर है वो कहाँ पे यूज होगा, जहाँ पे आपका हाइड्रोपोनिक्स है। वहाँ पे क्या होगा, आप इरिगेशन फर्टिगेशन करेंगे, सोइल है नहीं तो वो अपने में स्टोर करके नहीं रखेगा। सोइल है तो क्या होगा कि आपका सोइल बेस्ड नहीं है, सोइल लेस मीडिया है, तो क्या होगा कि आप जो भी इरिगेशन फर्टिगेशन करेंगे वो सारा इरिगेशन फर्टिगेशन में से जो भी क्रॉप की रिक्वायरमेंट रहेगी वो उसमें से ले लेगा। बाद में जो भी आपका इरिगेशन फर्टिगेशन है वो एक लाइन के थ्रू ड्रेन इरिगेशन वाला जो पानी है उसको हम फिर से रीयूज कर सकते हैं। तो उसके लिए ड्रेन ECPH सेंसर्स वहाँ पे यूज होता है। तो अभी हम एक एक सेंसर्स के बारे में बात करेंगे। डिजिटल मैंने सेंसर जो बोला उसमें एक है वाटर मीटर। तो वाटर मीटर कहाँ पे यूज होगा, आपका जो मेन लाइन जा रही है, फिल्ट्रेशन सिस्टम से और आपका मेन वाला गया, उसके बाद में जो भी आपका पानी फील्ड में जा रहा है हेड यूनिट के बाद वहाँ पे पहले वाटर मीटर लगेगा। वाटर मीटर जो है वो जो टाइप के सेंसर है वो डिजिटल टाइप का सेंसर है। ये क्या करेगा, इसका काम यही है कि आपका वॉल्यूमेट्रिक इरिगेशन करना, मतलब आप वॉल्यूमेट्रिक इरिगेशन कर रहे हो तो आपको कितना लीटर पानी देना है प्लांट को, 1000 लीटर, 5000 लीटर, 20,000 लीटर्स, जो भी आपने प्रोग्राम किया तो उसके अकॉर्डिंग अगर आपका 20,000 लीटर पानी जो है वो पर्टिकुलर प्लॉट में चला गया, उसके बाद वो आपकी इरिगेशन को और फर्टिगेशन को बंद कर देगा। तो उसके लिए जो सेंसर यूज होता है वो वाटर मीटर है। वाटर मीटर आपका जो भी अगर आपने टाइम बेस्ड इरिगेशन किया और वाटर मीटर लगाया हुआ है तो भी वो डेटा स्टोर करेगा कि इसमें आपने इतने टाइम में आपका इतना पानी गया था। उसके लिए वाटर मीटर्स यूज होते हैं। ये जो है वो 2 इंच से लेके 12 इंच तक डिफरेंट डिफरेंट साइज में आते हैं। ये उसका डायल है, मतलब कि रीडिंग्स जहाँ पे ये वाटर मीटर घूमेगा ये मीटर क्यूब में हमें रीडिंग्स शो करेगा। मतलब कि यहाँ पे अगर 1 मीटर क्यूब दिखाया तो आपका 1000 लीटर पानी जो है वो फील्ड में इरिगेट हुआ। ये जो डिफरेंट रेड सेंस जो ये जो डिजिटल का लगे हुए कांटे, ये क्या करेगा कि आपका जो भी पानी जा रहा है उस टाइम पे वो मूवमेंट करके उसका कैलकुलेशन करेगा। तो जैसे ही आपका 1000 लीटर पानी गया कि यहाँ पे जो डिजिट है 000 वहां पे लास्ट में चेंज होके 1 होगा, 2 होगा। तो एक डिजिट घुमा वैसे जैसे ही आपका एक डिजिट चेंज हुआ वैसे ही आपका 1000 लीटर पानी गया। स्टैंडर्ड जो है 16 बार तक यूज कर सकते हो, और हाई फ्लो जो मॉडल है जहाँ पे आपको आपका प्रेशर ज्यादा रहा तो 25 बार तक के भी मॉडल्स अवेलेबल रहते हैं। वाटर मीटर को जब आप इंस्टॉल करते हो तो आपको ये देखना है कि फिल्टर्स के बाद में आपको वाटर मीटर लगाना है, लेकिन किस तरह से लगाएंगे? फिल्टर्स के तुरंत बाद नहीं लगाते हुए उसके 5D और 2D डायमेंशन जो है वो आपको देखना है कि आपका जो 5D मतलब कि आपका जो पाइप है वो कितने इंच का डायामीटर है, आप मेन लाइन में कौन सा पाइप यूज कर सकते हैं उसके अकॉर्डिंग इंटू 5 करना है, और उतनी स्पेस छोड़ने के बाद में आपको वाटर मीटर इंस्टॉल करना है। प्लस आपका जो भी इरिगेशन हो रहा है, जो भी आप इरिगेशन कर रहे हो उसमें आप जो भी पाइप यूज कर रहे हो, सपोज आपने 4 इंच की पाइप यूज की तो वो 4 इंच की जो पाइप है वो 70 से 80% भरी हुई होनी चाहिए, मतलब कि पानी आधा नहीं जाना चाहिए। अगर आपका पानी पूरी पाइप ना भरते हुए 20%, 30% या 40% जा रहा है तो वाटर मीटर जो है वो प्रॉपर मेजरमेंट नहीं कर पाएगा। तो आप जो भी पाइप्स यूज कर रहे हो
Hello.
System here you can see 10 ton FIM.
नेटासेंस मॉइस्चर सेंसर जो है जहाँ पे आपको वाटर लेवल के अकॉर्डिंग आपको जहाँ पे इरिगेशन करना है मॉइस्चर कंटेंट के अकॉर्डिंग वहाँ पे नेटासेंस यूज होता है। ये जो है मॉइस्चर सेंसर्स हैं। नेटासेंस जो है ओपन फील्ड में मेनली यूज होता है। अगर आपका सोइल जहाँ पे सोइल मीडिया रहा वहीं पे नेटासेंस जो है यूज होता है। उसको 12 वोल्ट डीसी उसका ऑपरेटिंग जो है वोल्टेज देना पड़ेगा। 4 to 20 मिली एम्पियर उसका करंट रहता है। उसके 4 to 20 मिली एम्पियर के करंट के अकॉर्डिंग ये क्या करेगा कि आपको मॉइस्चर के कंटेंट देगा। अगर हमने इसकी वैल्यू सिलेक्ट की कि 7 to 45 सॉरी 0 to 50 इसकी वैल्यू है, और अगर हमारी वैल्यू 0 मिली अगर हमें सेंसर्स का गया तो उसके आप अकॉर्डिंग वो 0 एम्पियर 0 वैल्यू शो करेगा। मतलब कि वोल्टेज देंगे 20 मिली एम्पियर करंट वो करेक्ट ये करेगा, तो उसके अकॉर्डिंग आपका जो है आपकी लैंड वो पूरी वेट है। ये क्या किस तरह से काम करता है? सेंसर्स मेजर द स्पीड ऑफ एन इलेक्ट्रोमैग्नेटिक वेव। आपके जो भी इलेक्ट्रोमैग्नेटिक वेव है उसकी जो भी स्पीड्स है वो जो भी सॉइल्स है उसमें मेजर करता है. The most accurate methods of measuring water content in soil. आपकी जो भी सॉइल रही उसमें मेजरमेंट के लिए सबसे एक्यूरेट जो है वो ये नेटा सेंस है. ये नेटा सेंस जहाँ पे भी आपको इंस्टॉल करना है फील्ड में, वहाँ पे 2 सेंसर्स लगते हैं. एक सेंसर ऊपर की साइड और एक सेंसर नीचे डाउन साइड लगता है. तो जो भी आपका सेंसर है वो 2 सेंसर लगेंगे, एक ऊपर की साइड एक नीचे की साइड, अप साइड और डाउन साइड्स. तो जैसे ही डाउन साइड्स से आप हमें सिग्नल मिलेगा कि हमारी जो लैंड है वहाँ पे मॉइस्चर है वो कम हो गया, तो इरिगेशन स्टार्ट करने के लिए, और ऊपर की साइड जो है इरिगेशन स्टॉप करने के लिए, मतलब कि पानी ऊपर तक मिल गया, तो उसके अकॉर्डिंग 2 सेंसर्स यूज होंगे. उसकी वैल्यू डिफरेंट डिफरेंट रहेगी. ये जो सेंसर्स है टेंशियोमीटर से, तो वो मिली बार में सेंटी बार में आपको वैल्यूज देंगे. डेटा सेंस जो है वो आपको रेफरेंस वैल्यू देगा. तो 7 से 45 मतलब कि 7 वैल्यू मिली तो आपका जो है लैंड, जो आपका मॉइस्चर है वो टोटल डाउन है, मतलब कि 0 मॉइस्चर है. और 45 मिली तो आपका जो मॉइस्चर है सबसे ज्यादा है. उसके अकॉर्डिंग सेंसर्स यूज होंगे. डिफरेंट डिफरेंट मॉडल में आते हैं. एमएच सेंसर सूटेबल फॉर मॉइस्ट सॉइल्स, सूटेबल एसएस सेंसर फॉर सैंडी सॉइल्स, और हाई सैनिटरी और क्लेरी सॉइल्स जो है उसके लिए एचएस सेंसर. तो जो भी आपकी सैंड रही उसके अकॉर्डिंग अलग अलग सेंसर्स आते हैं. फिर ये रहा, ये जो है वो है टेम्परेचर ह्यूमिडिटी सेंसर्स. जब आपका जो भी ग्रीन हाउस में टेम्परेचर और ह्यूमिडिटी मेजरमेंट करना है उसके अकॉर्डिंग जो है टेम्परेचर और ह्यूमिडिटी सेंसर्स यूज होते हैं. ये क्या करेंगे कि जब आपका टेम्परेचर बढ़ेगा तो उसके अकॉर्डिंग आपके जो भी क्लाइमेट कंट्रोल में जो भी आपके ग्रीन हाउसेस में आपने फैन लगाए हुए हैं, पेड़ है, उसे ओपन कर देगा तो आपका टेम्परेचर कंट्रोल होगा. ह्यूमिडिटी के लिए ह्यूमिडिटी सेंसर है, ह्यूमिडिटी के अकॉर्डिंग वो फोगर्स ऑपरेट कर देंगे. तो ऑटोमेटिक जो ये फैन, पेड और फोगर्स के ऑपरेशन के लिए टेम्परेचर ह्यूमिडिटी सेंसर्स हैं. ये उसके कुछ कनेक्शंस दिखाए हुए हैं कि उसमें किस तरह से आप कनेक्ट कर सकते हैं. उसके बाद में वेदर स्टेशन है. तो वेदर स्टेशन क्या है कि ओपन फील्ड में यूज हो सकता है. अब जूनागढ़ एग्रीकल्चर यूनिवर्सिटी में रिसेंटली ही वेदर स्टेशन इंस्टॉल किया गया है. ये क्या करेगा कि आपका जो भी डेटा है, जैसे कि टेम्परेचर, क्लाइमेट के बाहर, आपने ग्रीन हाउस के बाहर जहाँ पे यूज करना है उसको आउटसाइड टेम्परेचर बोलते हैं. आउटसाइड टेम्परेचर, ह्यूमिडिटी, फिर विंड स्पीड, विंड डायरेक्शन, सोलर रेडिएशन, रेन सेंसर, बैरोमीटर, इवापोट्रांसपिरेशन, ये सारे जो डेटा है ये हमें ये सेंसर्स शो करेंगे. टोटल 10 टाइप्स ऑफ डेटा जो है हमारे वेदर स्टेशन हमें शो करते हैं. रेन सेंसर के अकॉर्डिंग हम इरिगेशन कर सकते हैं. टेम्परेचर ह्यूमिडिटी के अकॉर्डिंग हमें पता चलेगा कि टेम्परेचर बढ़ा है तो इरिगेशन रिक्वायरमेंट बढ़ेगी, कम होन करनी है. उसके अकॉर्डिंग ये वेदर स्टेशन है. ये उसके कुछ कनेक्शन दिए हुए हैं. विंड स्पीड के लिए जो ये है आपने कहीं पे देखा होगा इस तरह उसके सेंसर्स लगे हुए होते हैं. ये जो है विंड डायरेक्शन दिखाएगा, विंड स्पीड दिखाएगा. ओके, थैंक यू. नाउ एनी क्वेश्चंस?
Thank you. Yes, there are some questions in the chat box. One by one, we are discussing. Very first, okay, from Parth Kapupra. Very first question is from Parth Kapupra. Sir, is it affordable? Can I do chat? Yes, sir, is it affordable to small and marginal farmers? As in India, about 86% farmers lies in small and marginal category. So, Mr. Yes, can you explain is this technology is affordable to the small farmers?
Yes, recently हमने नेटबीट जो है वो लॉन्च किया हुआ है, जो स्मॉल फार्मर से 2 हेक्टर से लेके 1 हेक्टर से लेके 5 हेक्टर तक वो यूज कर सकते हैं, जो कि प्राइस में अफोर्डेबल है। और उसके अकॉर्डिंग फर्टिगेशन करने के लिए जो मैंने बताया, फर्टिगेशन जो 41 चैनल्स करके है वो लॉन्च हुआ है। रिसेंटली ये दोनों प्रोडक्ट्स लॉन्च हुई है, जो सिर्फ इंडिया के जो स्मॉल फार्मर्स है उसको ध्यान में रखते हुए लॉन्च किया है।
Okay, so yes, what is the cost of that
प्लस
particular?
हम उसके ऊपर और भी कि उसकी कॉस्ट कैसे, और बाकी जो इंडियन फार्मर्स है वो उसको कमर्शियल लेवल पे यूज कर सके उसके लिए।
Okay. Another question is from NS Mohammed. Which type of main market segment is targeted by NAHEP India? Greenhouse farmers or open field farmers show more interest and acceptance to auto-dosing fertigation systems. Do you have any presence in Kerala, dealer, any project reference? आप yes,
Sorry sir,
आपका targeted जो है greenhouse
there was some
farmers है या open field
interruption
farmers?
there was some interruption. Please can you repeat the questions?
Okay, which type of main market segment is targeted by NAHEP in India? Greenhouse or open fields?
मेन जो हमारा टारगेटेड फील्ड है वो ओपन फील्ड्स और ग्रीन हाउस बहुत दोनों ही है, लेकिन जहाँ पे भी जो भी हमारी प्रेजेंटली न्यू लॉन्च सिस्टम्स है उसमें हम जो है स्मॉल फार्मर्स को भी टारगेट कर रहे हैं। बाकी जो बड़ी सिस्टम्स है ECPH कंट्रोल करके, जहाँ पे वो जो सिस्टम्स है वो उसमें लिए जो हमारे टारगेटेड फार्मर्स थे वो ज्यादातर मीडियम से लेके बिग फार्मर्स जो थे वो टारगेटेड थे, लेकिन रिसेंटली जो सिस्टम्स है उसके अकॉर्डिंग हम स्मॉल फार्मर्स को भी टारगेट कर रहे हैं।
Okay, very good. Now another question from this same fellow is, do you have any presence in Kerala?
Yes, we have presence in Kerala. Our dealers are available at there, and some of these NetBit systems are also installed in the Kerala. I will share the contact details for the.
Okay, okay, sir. Okay. And any automation project has been carried out in the Kerala?
Yes, maybe presently within a month ago, once this NetBit systems only for irrigation has been installed. I will also share the details of the farmers and dealers in this list.
Okay, okay, very good. Now another question from engineer Chitra. That is standard irrigation and fertigation process for vegetable, banana and coconut.
Sorry, I cannot understand the question. What is the question for irrigation and fertigation? What they required?
The fellow is required the fertigation dosage for the vegetables, banana and coconut.
Means maybe he required this plan how much fertigation we need to be given or how much irrigation should we do. That's the data he required. Yes. So yes, our agronomist, we have recently talked that we have agronomist supports also available at there. We are providing that support, so he will provide the how many water requirement during the different seasons, and for different crop how many fertilizer and which type of fertilizers need to be given, or according to the disease come in this plant, according that also they will provide that now during this time you have to use these types of fertilizers, this type of chemicals. So that types of standard data.
Hello guys.
Yes, yes.
Wait.
We provide, of course, we are already provided with these systems.
Okay. Another question is, who are the Indian origin competitors of NAHEP?
Sorry, what?
Who are the Indian origin competitors of
Morning, bhai.
कॉम्पिटिटर्स में तो जो है हमारे जो भी डिफरेंट अभी कंपनीज है जिसके पास ऑटोमेशन है, दैट्स द कॉम्पिटिटर. So maybe there are different companies who is available and they are providing the things that are the competitor.
Okay.
We will not take any company's name in here, but okay.
Okay, no problem. Next question, please. Pump capacity needed for nitrogen and fertigate. How much pump capacity is required to operate nitrogen and fertigate?
For minimum flow, this pump capacity for the minimum flow is 5 meter cube. For operation, for you need to be used these fertigates or netajets. Maximum flow according we have models available, but your minimum flow should be 5 meter cube per hours. After suppose your flow is more than 120 meter cubes, then the different models we have available in fertigate and also in netajet.
Okay. Another question is for solenoid valve, whether we need pump connection or we can directly connect to tank.
Hello. Yes.
Hello.
Can you hear us?
Yes, please tell me.
For solenoid valve, whether we need pump connection or we can directly connect to tank.
Okay. For solenoid valve is used where you used manual valves in field. Solenoid valves are used in the fields. So for the solenoid valves, you require the controllers, and from controllers to the solenoid valve, you need to give the wiring. And for this irrigation tank or fertigation tank, you need to be connect through the fertigates. Well, Bakara valve, this one type of solenoid valves is already connected with that. So there is no need to connect tank valves between the tanks and the controllers, but the solenoid valves you can use with wiring. So it that's need to be connected through wiring. And this relay, pump relay is where to be used. Suppose you will connect the valve to the valve with controller through wiring, but you need to also start the pump automatic. So for that you will require this relay box to start the pump automatic.
Hello, sir. Hello. Can you hear me?
Yeah, please.
Yes.
Yeah, myself, Anis from Kerala.
Yeah, okay.
Yeah, sir. This time you said that the dosing system, the fertigation system, was started in India since 1965. So my question is, you know, countries like in Western, this type of systems are very common in European countries, especially in UK or Holland, and in Middle East as well, in Arabian countries like Dubai, Saudi, like that. But when you look at the Indian ecosystem, the marginal farmers, and what is the scope and challenge of implementing and executing such system in Indian ecosystem, especially the government support in European, in Europe, the government support in big way in subsidies and grants, for such, technologies. So they have good, the quality of the crops are very good, the health is good, and the produce also very good. So what are the challenges you face in, doing such projects in India, and what is the scope in India?
See, in India, there are 80%, near about to approx 80% are small farmers. So maybe they cannot afford this high ECPH control systems or this. Therefore, we have recently launched this NetBit systems, which 41 systems, which are for targeted small farmers. But as you know, the subsidies are not available in drip irrigation. Our by state there are different subsidy for drip irrigation, but in Gujarat, where in GJRC we also try to convince the government for subsidy also for automation systems. And presently in our only for Gujarat model, in GJRC they are providing subsidy for 2-inch solenoid valve, not for the automation these controllers or for the fertigation systems, but they are provided the subsidy for solenoid valves. So maybe in the future days,
Yes, go ahead.
Challenges is major challenge very small. So what here in Karnataka also there are one this Ramthal projects So what government done? They provide the common systems for the numbers of farmer group. So before this lecture, there was Maravia sir's lecture. In that also they provided the information that we are going to give some digital farming systems to our Gujarat at Halwad and Sabarkantha. So like that, what government can do that they give these systems to the small farmer group. Means they need to be join some farmers and some type of area. They need minimum area they can take, and after provide the subsidy on that area group farmer. So maybe in the upcoming days they can give this subsidy on that.
Okay, thank you, sir.
Okay.
Our next question is that bridge system is installed in Western Maharashtra region.
NetBeat system in where installed?
Western Maharashtra.
Actually, I don't know the which state about they are asking. Western Maharashtra means which
Western
states? Sorry, which cities? Which cities?
I think that is the Konkan region.
Which cities nearby? Maybe one or two cities
nearby. Mumbai to
Pune. Yes. There are maybe 2 or 3 NetBeat systems. NetBeat small farmer for the small farmer, and one is near about to Pune, maybe 2 hours from the Pune of the Sangli side. There are 2 or 3 systems installed for this NetBeat with 41 for the small farmers and big net MCU for the big farmers.
Okay, yes. क्या आप यहाँ पे NetBeat यहाँ पे भी लगाया है आपने all over India? उसका कुछ डेटा यदि आपके पास है, तो can you share?
Okay. After the 15 minutes, I will ready the data. I have some of the data available.
Okay. Next lecture आपका जब आएगा तब आप कर सकते हो.
Hello. Yes.
Video question है? Okay. I think all the questions raised by the participants has been resolved, and I would like to thank Mr. Yes Parekh, who is my friend also. He has given the nice presentation on the components of automation, automatic irrigation systems. Okay, and all kind of products available with NAHEP in India has been discussed over here. Thank you, Yes, for such a nice presentation. Thank you very much. Attendance for the participants. Attendance link has been saved by Jainis Kelaya in the chat box. You fill the attendance, and we will meet afternoon at 3:30. So kindly join from 3:15. Okay, so we will meet afternoon 3:15. Okay, thank you very much. And technology in the year 2006. After that, he has joined Jain Irrigation Systems Limited, Jalgaon, as a sales engineer. Thereafter, he has joined International Tractors Limited as a senior territory manager, senior territory executive, Then after again, he has joined Jain Irrigation Systems Limited, Jalgaon from 2007 to 2015. Then after he has having the work experience with the government of Rajasthan as a junior engineer in the Department of Watershed Development and Soil Conservation. Again he joined Jain Irrigation Systems Limited, Jalgaon since March 2017 as a state head of Rajasthan. He is handling micro irrigation, pipe products, fuel pumping system, and tissue cultural products selling. And he has wide experience in the field of micro irrigation system. He, as a micro irrigation engineer, he has very much experience. He has traveled over 1 million kilometers in interior of Rajasthan for the sales and marketing. This kind of distinguished expert with us. It is we are enough to fortunate to hear him. I did two topics. Okay. The topic today he will discuss is on advanced irrigation scheduling techniques. So, how to schedule the irrigation? What are the advances in the irrigation scheduling? It will be discussed in this lecture. So, I would like to welcome Engineer Bharat Soni. Bharat bhai.
Thank you, sir. Just a minute. Is the slide visible? Hello.
Yeah.
Yes, sir.
Yes. Okay, thank you. Just a minute.
Sir.
Firstly, good afternoon, all of you. Am I audible?
Yes, sir.
Yes, sir.
Firstly, I will want to give the thanks to Dr. N.K. Dotia Saab, Dr. S.D. Ran Saab, Mr. Janice, and the other faculty member of the College of Agriculture and Technology, Junagadh, for giving me such a great chance to interact with the final year students of BTech Agriculture in this 5 days vocational training on automation in micro irrigation. Firstly, in first slide, I will want to discuss about the present agriculture scenario. India is having approximate 14% of the total population of the globe, and this population is continuously rising year by year. A study says that it is expected that in year 2025, this population will grow up to the 1500 million, and it will cross around 1700 million by 2050. To feed such a vast population, we need to increase our food production too. Although one we have to increase and have to work on the food production, how to increase the food production, but there are some constraints in the food productions. What are the hindrances which faces in the food productions are? First is the loss of the agricultural land due to urbanization. Due to increase in the urbanization, the area undercropping rate reduces day by day. The shortage of water and its pollution, irrigation problem, climatic changes, and the shortage of the arable land and the land degradation are the hindrances in increase the food production. Then a question arises on what ways we can increase or improve the productivity. There are 3 different ways by which we can increase the food production. First one is by introduction of high-yielding hybrid varieties. During the first Green Revolution, this alternative was tried and found that the use of hybrid varieties, even they are high-yielding, but they are having some limitations. Many times the hybrid variety brings disease along with them, and they are more prone to disease rather than the original indigenous varieties. The second way by which we can improve productivity is by increasing the area under cropping. This alternative also has some limitation. Everyone knows a fact that due to the growing urbanization, the area under cropping get reduced. Only the area under irrigation or the under crop will be increased by adding the additional wasteland under cultivation. And the third way, that is by increasing the area under irrigation. This is the most practical and the technical feasible solution by which we can increase the agriculture productivity, or by time we can improve the agriculture productivity. By increasing area under irrigation, we can definitely increase the productivity of the crop without any limitation or side effect, which we face in the case of hybrid varieties such as disease. However, there are some exceptional cases where because of the over-irrigation, the soil may become saline or the alkaline. But this problem can be taken care by judicious use of available water resources by introducing modern irrigation techniques such as drip and the sprinkler irrigation. In summarize, we can say the irrigation and the judicious use of the water resources available plays a vital role in the increase the production of the crop, and I personally feel that is the only solution to increase the food production, and thereby we can only provide the food to the all. Now we will look after the present water scenario. The worldwide, we see the total available, only 3% of the water is the fresh water. And in Indian context, there are only 4% of this 3% fresh waters, 4% is only available with us. The population is continuously rises, thus the available per capita fresh water is continuously coming down and decreasing due to increase in the population. Other than this, due to the increased demand on the other sectors, also increasing and lapse of the time, just the availability of the water is constant, or rather it is decreasing. The demand, the study says that the demand will process the availability before 2015. Here a table, there is a data shared by the Ministry of Water Resources, Government of India, New Delhi. It shows that by year 2050, the water demand from the all sector will be around 1180 BCM, while the available water or the utilizable water is around 1123 BCM only. Thus, the judicious use of the available water resources by using drip and sprinkler irrigation is the only way to overcome this situation. Because if we see this table, the maximum water is utilized under irrigation. This is around 75 to 80% water, which is utilized by the irrigation only. Now we will discuss on the present topic, the topic of the today's seminar, that is irrigation scheduling under micro irrigation. Irrigation scheduling means how much the water is applied, at what time the water is applied, to meet out the evaporation losses and the water used by the crop. It is a wide subject. It depends upon the many factors. Before irrigation scheduling, we will discuss each topic, each points one by one to come up to the irrigation scheduling. For proper irrigation scheduling, firstly, we have to know the soil-plant water relationship in the micro irrigation. When we say the soil is a storehouse, we can say the storehouse of the plant nutrients and the medium through which the water and nutrients move into the plants. Characteristic of the soil widely varies to their physical properties, often determining the type of the crop which can be grown in the particular soil, and also the type of the irrigation system which is appropriate for the particular type of the soil. Thus, the thorough understanding of the soil property is very important for the purpose of irrigation system design and later for the scheduling of the irrigation system. Firstly, we will go through the different characteristics of the soils on the different property. Firstly is the texture. What is the soil texture and how it is effect on the planning of irrigation system? The soil texture, it is refers to the relative proportion of the various size of the material, particularly such as sand, silt, clay available in the particular soil sample. The soil texture plays a vital role in the process which governs water movement, water holding capacity, and the available and the retention of the nutrients in the soil. The second terminology is the soil structure. Soil structure is different than the soil texture. Soil structure means it refers to the aggregation in which the soil particles are arranged in a arrange this type of the such as single layer or the granular, platy, blotty, etc. These are the different different type of soil structures. We study the influence of the soil structure while designing the drip irrigation or any micro irrigation system. The soil structure influences on the moisture relationship, water movement, availability of the nutrients, root development, and the plant growth. Other than this soil texture, soil structure, there are three more things we have to know before designing a irrigation system or before scheduling the irrigation system. One is soil mass. The soil mass, we can say, is the three-phase system. It consists of the soil particles called soil grains, water and air. The space between the soil grains is partially filled by the water and partially by the air. These also plays a vital role in planning or scheduling the irrigation system. Then another terminology is tilth. Tilth refers to the physical condition of the soil in relation to the plant growth. Soil is in the good condition, is easy workable and take water readily. On the other hand, if the soil is poor tilth, it is hard, cloddy, difficult to work, take up water slowly, and have poor drainage. Now we will show how the soil structure, soil texture affects the wetting pattern and the planning of the whole irrigation system. In it, when water is applied slowly to the soil at a single point, it is acted upon by the two forces. First one is the gravity, which forces the water downward, and the second is the capillary, which forces water radially outward, producing different pattern depend on the soil type and the application rates. In the first case, where there is a sandy soil is characterized by the large voids between the soil particles. These large voids are relatively weak in capillary forces, but little resistance to gravitational flow. But the result that the lateral upward water movement is limited and the downward water movement is the rapid. In the another case of the heavy clay soil, clay soil have the strong capillary forces but resist to the downward water movement. Thus, the water moves radially more as compared to the downward movement. These all the soil plays a vital role while selecting the emitter discharge, number of emitters, while planning the irrigation system. Now, we will know how the plant react with the water available in the soil, or we can say we will study the plant water relationship. We can say the plant cells and intercellular space absorb water by osmosis and imbibition. The osmosis water moves from the area of the lower salt concentration through a semi-permeable membranes to an area to an area of the higher salt concentration. By imbibition, water molecules are tied by the hydrogen bonds to the cellulose and the other water attracting material in the plant. The water normally moves from the soil saturation through the semi-permeable cells to the inside of the cell. We can say the plant moves the water and nutrients upward through the xylem tissue to the leaves, and through it is released through the leaf cell called stomata. Now we will discuss about the absorption of water. Under natural condition, practically all water absorbed by the root plants taken place through the root system. The area of the root where the most of the absorption takes place is the root hair. Water diffuses into the root hairs as the result of water potential gradient. As long as the potential of the root cell is more negative than the solution, more water enters into the cell and then leaves it. Now we will study what are the factors affecting the absorption of the water. These all factors affects our irrigation planning and how its scheduling should be done. The first factor is temperature of the soil. The soil temperature has a profound influence on the rate of the water absorption. At the lower soil temperature, the water absorption goes down because water is more viscous at the lower temperature, which this factor reduces the mobility of the water, and the root growth inhibits at this low temperature. The second factor that affects the absorption of water is the concentration of the soil solution. As we know, the water absorption, because of the potential gradient exists between the soil solution and the sense of the interior root cell. This is only due to this potential difference. The water enters into the plants through the thin membranes. Third is the aeration of the soil. There are the several reasons for the poor aeration having effect on the absorption of the water. Root growth, metabolisms are also directly affected by the lower availability of the oxygen into the soil. The fourth point is the availability of the soil water. Not all of the water available in the soil is immediate close area of the root system of a plant. Which depletes the plant's water need. The absorption of the water by the plant becomes more and more difficult. If the water is more away from the root zone, it is very difficult for him to take the water intake. And the last one is the characteristic of the rooting system, which affects the water absorption. Since the root system of the different plants, if we see the different root system by seeing, we found that some roots are deeply penetrated and some are expanding laterally. The different root characteristics have the different capacity of the absorption. Now we will a short look on what are the different functions of the root system. First, only absorption. The most important function is the absorption of the water and the food material from the soil. This is done with the help of the root hairs, which develop in the cluster at a little distance behind the root hair. These root hairs adhesive the soil particles and they absorb the water and the soluble salts from the soil. The second is the conduction. The water which was observed and intake by the root hair, the root is also concerned in the conduction of the water and the mineral salt, sending them upward into the stem and ultimately to the leaf. And the last one is the storage. A certain amount of food stored partially in its maturation region. As root grows, this stored food is utilized. It may be summarized that the soil is used as the anchorage, conduction, storage, and the carried out on the normal are carried out on the normally by the older portion of the root, and the absorption of the is by the root hairs and the tender portion. Now we will discuss about the plant water requirement. We know the optimal growth of the plant depends upon the plant having readily access of the water. All the plants processes requires water. The plant losses majority of the water in the process called the transpiration. In the plant, all the leaves are covered with a teeny pores called stomata. The water passes through these as a water vapor to the atmosphere is called the process of transpiration. The plant regulates its water requirement by closing stomata if it cannot draw the water from the soil. Suppose a situation is there is the less water available and the potential radiance is not available to take the water into the plant. The stomata become closed to reduce the transpiration losses. This results we also know the carbon dioxide, which is also an essential part of the plant growth, also enters through this stomata. And if they are closed in account of water stress, the plant growth will stop. The aim of any irrigation scheduling is to ensure that the plant is adequately supplied with the water from the soil water reservoir at all the time. The rate at which the plant loses water by the transpiration may be approximate by the rate of the evaporation from an open pan evapometer. The measurement together with the rainfall reading enables irrigation scheduling to be carried out by a farmer. Now, before going to the irrigation scheduling, firstly we will give a close look over what are the micro irrigation system and what are the different components and how the system is designed. The micro irrigation system, we can say, is a method which saves water and the fertilizer by allowing water drip slowly to the root of the plant, either on the soil surface or directly into the root zone through a network of valves, pipes, tubing, emitters, etc. The micro irrigation system has the different type of the irrigation system. This may be drip irrigation, the sprinkler irrigation, mini sprinkler. All are the terms under one terminology, micro irrigation. In micro irrigation, every micro irrigation system is a pressurized system. Thus, the main heart of the micro irrigation system is the pumping unit, which generates a required head to feed the emitters and to deliver the required application rate at the required place. The second is the filtration unit. The filter station or the filtration unit allows the clean water to enter into the main lines and the sub-main lines to avoid the clogging of the emitters and the pipelines. There are the different type of filters. It depends on the impurity available into the water source. There may be sand separators. The sand separators works on the principle of the in this hydrocyclone separators. The water enters and it creates a cyclonic movement inside the filter. By this, the heavier particles of the sand settle down into the collection chamber, and which will be collected and taken out. The second filter is the sand filter, which is used to separate the suspended particles such as leaf, algae, and the higher side impurities from the water. And the third filter is the stream filter, which is used to separate or to protect the system from the fine impurities such as silt, sand, to enter into the pipeline. Then the fertigation unit may be fertilizer tank or the venturi. This is used to apply the fertigation with the irrigation. After the filtration, the water enters into the network of the pipes. The pipes may be of PVC or HDP. Then the control valves come. The control valves may be non-return valve, pressure reducing valve, gate valve, ball valve, which can be used to regulate the section in which the water may be applied in the irrigation system. The water after main line enters into the sub-main line. This may be again of the PVC or the HDP. From sub-main line, the water enters into the LLDP laterals, and then through the emitters, water is applied to the directly to root zones of the plant. Here we will see a clip on how the irrigation system works, or how the drip irrigation or the micro irrigation system operates. From the water source, through the pumping unit, the water will be lifted with the required pressure, and after filtration, the water enters to the main lines and then conveyed to the sub-main lines of the different sections designed as per the irrigation scheduling. And then through the laterals, the required water is applied through the emitters directly to the root zones of the plants. This will save the water, fertilizer, reduces the labor cost, and provide proper plant growth and help in the increase in the productivity. Here we see the water comes through sub-main to laterals and then through emitters. The water is applied to the plant drop by drop at a measured or the designed application rate. Now, before understanding the scheduling of a irrigation system or the calculating, we have to know what are the different crop water requirement. Or before calculating water crop requirement, we have to take on the following points into consideration. First one is the type of the crop and its age. Every crop has a certain peak water requirement, but at different stages, its water requirement is different. And many crops, in case of the orchard crops, some crops such as pomegranate and mango, there may be in the cultivation practices, we have to at a certain time we have to apply the water stress to get the better fruiting. Second one is the type of the soil. We already go through how the soil affects the water movement in the soil, the evaporation losses from the surface, the canopy area and the root zone development of the plant, and the plant to plant spacing and the row to row spacing, velocity, wind velocity and humidity, etc. need to be taken before calculating the water requirement of a particular crop. Now for the scheduling or the water requirement of the plant, firstly we have to know what is the proper irrigation system scheduling and designing. It is necessary to firstly we will know what are the water requirement. In general terms, we can say the crop water requirement is equal to the evapotranspiration necessary to sustain the optimal plant growth. The accuracy of determining the crop water measurement is largely depend upon the different factors, climatic factors. While theoretically calculating the evapotranspiration, there are few methods. First one is the reference crop evapotranspiration. In this method, the evaporation from a the rate of evaporation from an extended surface of 8 to 15 meter tall green grass covered with the uniform height, accurately growing, completely shedding the ground, and with no shortage of water, we will calculate the total evaporation and then take it as a reference. The second one is by calculating the net depth of water, that is evapotranspiration of the crop. The evapotranspiration of the crop is calculating by knowing the pan evapometer, the evaporation losses by the pan evapometer, the pan coefficient, and the crop factor. The crop factor depends on the foliage characteristic, the stage of the crop, environmental, and the geographical factors. Generally speaking, the crop factor varies from the 0.4 to the 0.7 according to the, and it should be used for the horticulture crop. And the volume, now how to calculate the volume of the water for a tree crop. The volume of the water required in liter per day per plant. In case of particular, not this is in case of the tree plants, the total volume of the water required is calculated by determining the net depth of water, then multiplied with the percentage wetted area covered by the foliage, and then multiplied the plant to plant spacing, and then multiplied with the row to row spacing. And the volume of the water required for the row to row crop is net depth of water multiplied by crop factor multiplied by percentage of the wetted area covered by the foliage. Now, in many cases, the pan evapometer coefficient is not available with us. Then we will take it as 8 mm per day for calculating or the scheduling of a irrigation system or the designing of a irrigation project. Now we will go through an example how we will calculate the irrigation time required to irrigate a particular crop. Either it is a close spacing or is the wide spacing crop. Suppose the water requirement per square meter for a row crop with a crop coefficient of the 0.7 and the wetted area covered by the foliage at 0.5 will be by multiplying that pan evaporator coefficient that is equal to 8, then multiply it with the crop factor that is equal to 0.7 and the foliage percentage wetted area covered by the foliage, it comes around 2.8 liter per square meter per day. Then by calculating irrigation time required to reach up to this water requirement, we need we are going to irrigate this particular field. Suppose one is irrigating field using a drip line of 2 LPH having lateral spacing at 1.2 meter and emitters at 0.2 meter spacing. Then the discharge rate will be 2, this is the liters of the emitter discharge, and the emitter spacing, this means 6.67 liter per hour per meter, and the discharge per unit area will be around 5.57 liter per hour per square meter. Thus, the irrigation time required to irrigate this particular crop at particular stage is around 0.5 over, let's say, 30 minutes. Once we get this irrigation time, we can plan or we can decide our irrigation scheduling. The second one case is the case of the plantation or the orchard. Example, a water requirement of the coconut plant is around 100 liters per day per tree per day. If we are applying water by using 4 dripper on each plant of 4 LPS discharge, then the irrigation time will be the total water requirement divided by the application rate. That is equal to 6.25. Again, this application rate will be differ according to the climate, according to the soil, according to the plant stage. This particular irrigation time we will consider while designing the irrigation system, because we have to design the irrigation system on the maximum or the peak water requirement. We will taken this irrigation time taken in consideration of the designing of irrigation system. Now the question arises: what are the intervals between the two irrigation? It depends upon the different characteristics of the soil and the agroclimatic condition, stages and the age of the crop. The irrigation interval can be divided based on the following table. On one side, you will see the climate, different climates such as hot, dry, moderate, cool or low. And the second side, we will see that there are different type of soils. There is porous soil, light sandy soil or the clay soil, or the loam soil. In the hot season, where the soil is porous, we have to apply the water twice a day to avoid the deep percolation and the evaporation losses. Secondly, in case of loam soil, in case of hot and dry climate, we have to apply water in 2 to 3 day interval or twice a day, because the water is penetrating very slowly into the soil. To complete the irrigation water requirement, we have to divide the irrigation water requirement into the sections. Now we will see the different farm situation, different situation of a farmer. There is a one farmer who is using traditional flood or the furrow irrigation system. He is always becoming sad. Then the question arises: why he is always sad? He is always facing, firstly, the issue of the shortage of the water. Second, uneven plant growth. Higher cost of cultivation. And the last, the low production. This made this farmer always sad. Now the second situation comes when the farmer adopted the drip irrigation system in his existing crop pattern. Now he is feeling better, because now he is managing his way of irrigation and the fertilizer application. He reduces the cost of the labor and increases his productivity and the profitability. Now, the third and the most effective factor with the irrigation, when a farmer adopted automation with the existing irrigation, he is always happy, because now all things are in control. Hello, am I audible?
Yes, sir.
Yeah, thank you. Now we will need what is the automation of the irrigation system. Automation of an irrigation system refer to the operation of the system with no or the minimum manual intervention. The introduction of the automation in irrigation system has increased the application efficiency and drastically reduces the labor requirement. The farmer now the manage his system, his operation, his scheduling by his own way, depends upon the different crop stages, by program the same, and can apply the water as and when required. Thus he always feel the happy. Now we will see what are the different benefits of the automation system. The automation improves the quality of the crop, because the water is always applied on the time. the fertigation is applied at the right quantity and the right manner, the crop quality is improved. By the automation, we can manage the irrigation in the best way. We can save the optimal. We can save the water, optimum saving of the fertilizer. We can save the labor cost, and we can maximize the yield of the crop by using this automation system. Then a question arises: in case of automation, what are the different scopes of the automation? In case of irrigation, we see in case of micro irrigation system, there are the different points where we can apply the principle of the automation. The first one is the operation of the pump. We can manage the time, we can manage the on-off timing on the particular pump for the operation of the micro irrigation system. We can also manage the cleaning and the bed washing of the filtration unit. We can operate the field valves as and when required as per the in case operation is given in the pulses, we can also do using this automation. Soil moisture measurement is also possible using the automation. We can also monitor the weather. Also, we can use automation for alarm or display of the alarm during the malfunctioning. Now we will go through the different type of automation in the micro irrigation. The first one is the time-based automation. In the time-based automation, the controller operates on a set time. In this system, time is the basis of the operation, and the basic objective is to prepare the schedule as per the water requirement by the different plant, and the operation schedule will be set as desired. Earlier we had go through the how to calculate the how much time required to irrigate. By this way, by this time-based operation, once we get the how much time required to irrigate the particular field, we can program it according to the time-based controller and can automate the system. And the second one is the volume-based automation. In this volume-based automation, the water counter operates on the flow of the water. Suppose a user is required to give the 10,000 liter of the water in the particular field. Water counter will counts the water, and when it reaches up to the 10,000 liter, it will send the signal to the controller to turn off the pump and the control of the valves. It will save our resources. The third one is the type of the automation is the operation based on the sensors. In this, controller operates on the different on the signal received from the different sensors. In suppose a situation is that in case of time-based irrigation, the time is set for irrigation, but there is a sudden rainfall. The rain sensor which is installed with the system give the signal to the controller to no need to start the pump, and thus why will we can save the resource. On the type of the operating system, the automation system can be divided into the 4 different types. The first one is the hardware based, second one is the wireless based, third one is the hybrid, and fourth is the web based system. In hardware system, there is one product named Irrigation developed by the Chain Irrigation system. It works on the concept of the hardware, in which the hardware that is of the system, which is the controller named Irrigation, transmit the signals to the different devices attached with it. And the Irrigation is a time-based controller. It is available in different 4 models. This is having 4, 8, 16, and 24 outputs. The irrigator can operate 2 water pumps, 2 fertilizer pump. It is having the facility of the filter backwashing. The power required for is 24-volt AC through stabilizer and the 12-watt AC for display through adapter. We can plan the start and end of the day by using this irrigator controller. This irrigator controller have a very good features. That suppose we have planned for a particular irrigation scheduling to operate the valve at the time 2 p.m. till 4 p.m. and there is a sudden power cut at 3 p.m. and the again light comes at 4 p.m. This irrigation controller saves the programming and again the remaining irrigation schedule will start at the 4 p.m. and the next day the irrigation schedule will again repeat as per the planned or the feeded programmed way. This is the systematic layout of the irrigator controller by which we can, by using irrigator controller, we can control the field valves, which are solenoid valves. We can operate nutritious eco. This is a fertigation machine. The field backwashing of the filtration. We can operate the operation of the pumps by using this single controller, which is based on the time. The another controller, which is based on the which work on the hardware principle, is the Speed Pro controller. Speed Pro controller is the time-based, volume-based, and it's the sensor-based product, which is available in 2 models. First is 8 input and the 8 output, and the second is with 16 output and the 16 input. Controller have LED display card, and different control units. It's required power supply of the 24-volt AC to servo stabilizer. If more inputs or the outputs required, then the extension may be used with this type of controller. The another type of the controller which works on the wireless principle of the automation is the Speed Pro wireless. It is also a time-based, volume-based, and the sensor-based controller. It have analog and digital both type of sensor, can be connected with this type of sensor. All type of controls and the features are same as that of the Speed Pro hardware type controller. And this same model can be the same features which are available in the Speed Pro hardware type is available with the Speed Pro wireless type. As we will discuss, the Speed Pro controller has the capability of connecting wireless application by adding valves, sensor, etc. On the wire application, it can be operated seamlessly by up to the range of the 1.5 kilometer. Thus, the specially designed board called radio gateway card, which convert radio frequency, is been introduced into the system. On the other side, there is the remote terminal units, which are known as the RTU, these are connected on the same frequency which are received from the controller. These RTUs are having inbuilt battery of the power of the 3 volts. It has inbuilt solar panel. Therefore, it works without separate supply to the RTU. It has range, again, as discussed, to the 1.5 kilometer in the open field. RTU has the capability of connecting 4 digital output and can raise up to the 8 digital output. While extending the range, we can additional repeaters. We can repeat the 4 and 8 digital outputs. We can give up to we can connect around 100 RTUs with a single controller. Then the another way or the type of the automation system is the hybrid system. In the hybrid system, the Speed Pro controller is itself is the same as per the Speed Pro hardware type. It is the time-based, volume-based, and the sensor-based controller. It can control all type of fertigation and filtration unit. It can connect with the analog and the digital both type of the sensor, and can be connected with the hardware and wireless RTU with the wireless kit. This is the systematic layout of the hybrid automation system, in which the few devices are connected directly to the hardware, and the valves are operated using RTUs and the through gateways. The another way of the automation is the web-based irrigator system. In the web-based system, web-based system is based on the IoT base. In this, the program particular software named the Gen Irritator Global. The program is been made by the user, and it can plan his irrigation scheduling, and the signal transmit using the internet transmission. Here we will see a video on a project which we had executed in the state of Karnataka by using this Irritator Global.
Irrigation project, Ramthal Lift Irrigation Scheme, located at Taluk, Bagalkot district of
Is video is audible?
Ramthal project is initiated by Krishna Bhagya Jal Nigam Limited. The entire project is conceptualized on a revolutionary concept of resource to root. Taluk falls under the drought-prone zone of the state. Farmlands are literally starving for water. Farmers mainly grow rain-fed crops like gram, sorghum, chili.
We had executed this project in the state of Karnataka.
The sufferings of farmers' life by initiating Ramthal Marul Lift Irrigation Project.
This project we had planned from the initial from the resource where the water is available, and we had planned the entire area by using this Irritator Global Irritator Global. The irrigation scheduling was decided by our team. This Irritator controller provide the facility and give the
not only in India, beneficiary farmers are getting multifold benefits like doubling income and higher profits, assured irrigation for 2 crop season, can grow cash crops, reduction in fertilizer,
Videos are not visible to us.
soil health,
We cannot see the video.
market linkage and better price for produce. In a nutshell, Ramthal project will make agriculture sustainable and will bring prosperity for the beneficiary farmers. Government of Karnataka also benefited in many applied is increased to 1.
Hello. Video visible नहीं हो रहा है क्या?
No, sir, video is not visible.
Okay, चलिए मैं इसको फास्ट ले लेता हूँ. ठीक है. Hello. This project we have executed at the state of Karnataka. This particular software have the facility that what the program we have planned in it, when the wall is operated in the field, the farmer or the end user will get a SMS that what are the timing of the operation of the pump, at what time the pump is operates, and what amount of water is applied to this plant. There are the different type of the fertigation machines which can be used with the automation. There are different type of fertigation machines. They have EC and pH facility, or with or without the EC pH. There are the different models available with the fertigation machines. There is a Presimix. This is the advanced fertigation machine that mixes various kind of fertilizer and especially designed tend to achieve the desired EC and the pH. Now we will have a quick review over the over application wise how to select the automation system. Firstly, we have to request the farmer to know what are the system. This is centralized or the decentralized, wired or the wireless. Fertigation with ECPS meter or without ECPS meter, number of venturi in the fertigation machine, or the time or the volume base or the sensor based irrigation, the plot detail. If more plots to be irrigated from the one water source, then we have to provide. Then the one have to provide all the required detail like distance, obstacles, etc. between the each others. As we will study the different type of the controllers. The irrigator controller, which is the time-based operation, where the time-based operation is required, we can suggest the irrigator controller. And where the time, volume, and the sensors-based operation is required, we can use the speed pro controller. In case of polyhouse, we will recommend the speed pro controller, as it is compatible with all type of the fertigation machines, weather monitoring, 14, etc. can be controlled by using the speed pro controller. In case of open field irrigation, when the time-based operation is required, the irrigator controller can be used. In case where the time, volume, and sensor-based application is required, the speed pro controller can be used. For the big projects, the web-based wireless system can be recommended. There are the few key points. If after your education you are want to come into the irrigation business or the automation business, few support teams needed for a successful automation business. First one is the technical support team to provide the right product and the right solution to the end users. The sales support team, the logistics support, demo support, spare support, installation support, training support, and the last but not least, the price support. The price play the main role while selling the automation system. There are the different automation system installed at the different places. This is the Mr. Dinesh Tiwari of Gujarat. His installed system in the under pomegranate crop in 15 acres. Mr. Jinesh Singh of Madhya Pradesh. Mr. Amit Sharma from the Madhya Pradesh. From Nasik, Mr. Avinash. Mr. Ramdas. Mr. Sachin Patil. And now you are having any questions, feel free to ask.
Yes, sir. We have many questions in chat box.
Okay, I will see and reply one by one.
Okay, sir.
Okay. Just a minute. First one. There is a question from Mr. Anis that what are the advantages for a farmer who intend to buy a Gen irrigation system over NAHEP Israel India? Okay. Every product has our different features and specification. In case of irrigation system, as I explained earlier, it has having the unique features in the tribal areas where the irrigation, where the electricity supplied irritated, it is having the facility to override the time of the power cut, and the irrigation schedule will be continue after the power cut, and it is depend on the choice of the farmer to which system is adopt. Techno-commercial benefits. Yeah, techno-commercial. Yeah, in case of the automation, yeah, in case of this irrigation system, you will see the other controllers, different controller. I don't asking about any company particular product. The many controllers operates are the supplied by the different manufacturers are not the irrigation controller. They are basically the land step controller which are used as a time-based controller with the irrigation. These controllers, many controllers are not having the facility of overriding over the power cut. If you have planned a program to start the pump from 3 a.m. to 3 p.m. to 4 p.m. and there is a certain electricity or the power cut, the program will not shift further. The amount of drip irrigation increase the crop production. Yeah. What are the amount? This is the question by Mr. Durgesh. By what amount does drip irrigation increases the crop production compared to the flood irrigation? The drip irrigation, if there is not only the drip irrigation, if we apply the drip irrigation with the fertigation, definitely the crop production will increases. And a study says if the increase of the production goes up to 25 to the 40 to 50% higher as compared to the flood irrigation. The video, I think this is not visible to the all. In this, we have shared a study on the Ramthal project, which was executed at Karnataka, where we have compared the earlier production through the flood irrigation and the later after execution of the project, what are the new production comes with this drip irrigation. This pro huge conservation and the farm system control of micro why the government is not providing direct subsidy. No, in case of Gujarat, I am not having the particular idea about the government subsidies. In Rajasthan, the government just initiated a project to promote the automation system with the drip irrigation. As a pilot mode, they had spare a budget of around 16 crores on the particular this automation based irrigation system project. This is also incorporated with the irrigation and the fertigation machines too. Drip irrigation can be applied. The question is from Durgesh Datar. Drip irrigation can be applied in wheat, gram crop. Yeah, the drip irrigation can be applied in any type of the crop. Either it is wheat, gram. Even we had applied the drip irrigation system in the paddy crop. Then in district Kota of Rajasthan, there is a farmer, Mr. Patidar, who is awarded at the PM level, and he awarded 3 times for his effort with the drip irrigation on the cultivation of the paddy through the drip irrigation. Yeah. In the cotton crops, it can be used in cotton crop. Yes, definitely it can be used in the cotton crop. Cotton crop have a very good results with drip irrigation system. It will operate in a vegetable our project, but found difficult. If you are facing that problem in difficulty in the setup of the motor, this is depend on the programming of the controller or some hardware issue Yeah, the question comes from the Madhav that how much the cost increases in the automatic micro irrigation system than a simple micro irrigation system. This again depends on the what type of automation you are required. If you require simple automate or simply time-based automation system, it cost around 58 to 70,000 to operate 8 valves. If you needed a fertigation machine with this, it costs additional to the 78,000. And if you want to go for the speed pro controller for the volume-based, time-based, and the sensor-based operation, it will cost higher as compared to this retail system. Mr. Proje, the question comes from Harish Kumar Pondia. For this, you can contact me directly. My email ID is sony.bharat@gens.com. I again repeated for Mr. Mr. Harshi Kumar.
Yes, sir.
My mail ID is sony.bharat@gens.com. You can contact me directly.
Okay, sir.
Yeah, definitely. Good question from the Anish side. Definitely, the automation system is still not the very much promoted or very much adopted by the farmers. Still, we will see and not know the Gujarat situation. Gujarat is very much advanced in case of irrigation. In Rajasthan, still there are many areas are without the drip irrigation system. Thus, firstly, government have to take this initiative to promote the drip irrigation system with automation system with some grant from the government side so that the farmer can adopt and get the benefited by this, and by this can be replicated among the different farmers. Sir, for 50%, how many sensors? Type of pest. There is a question from Mr. Chitra. I am not understand for 50% how many sensors should need. Can you explain what you want to know? Okay. 50 cent area, I don't know. Cent is it is the measurement of the area in Gujarat. I don't know 50 cent area. Okay. It will depend how many sensors required. It depends on the type of irrigation system and the type of the sensors you are going to introduce with the system. Suppose you want to install the rain sensor. It is the only one rain sensor is sufficient for a particular area. Second, the type of the flow sensor. The flow sensor, we can apply the flow sensor with every section wall, or a single flow sensor with the delivery of the pump. Third one is the soil moisture sensor. It should be provided at the different levels, depending upon the different depths of the soil.
Sir.
Okay, thank you. Any questions?
Sir.
Yeah.
Sir, drip irrigation system can be damaged by rat. Sir, what can we do in case?
In this stage, the rat is the main problem. In the case of urban rural areas, the rats are cut the laterals. Now the few laterals are available. They are known as the anti-rodent laterals. They are coated with the special chemicals. When the rat cut the lateral, after once it cut, then again we will not come to cut the laterals. These are known as the anti-rodent laterals. Or we have to kill the rat colony available in the field. This is the only way. This is the only solution to protect the system by using from the rats. And in agriculture, we are facing one more issue. the beating of the laterals by the chip means गिलहरी. तो गिलहरी जो होती है वो लेटरल को काटती है पानी पीने के लिए. अगर गिलहरी वाला अगर इशू है अपने उधर गुजरात में, तो आप कुछ जगह पे पानी बांध के रखिए, तो आपका लेटरल को गिलहरी डैमेज करेगी. Cost of the system, ones which so in Madhya Pradesh for a farmer of the 15 acre. Yeah, the 15 acre, the automation system. Are you asking for, Mr. Anish, are you asking for the cost of the drip irrigation or the automation system?
Sir, automation system. Drip irrigation is okay. We all know.
The automation and the Madhya Pradesh farmer where he is using the system, I think in vegetable crop. I think. And the irrigation system, the automation system, is costing around 2,10,000, and the fertilization machine, which is the NutriCare ECPS meter, which is costing around 3,25,000.
Okay, so the mixing the NutriCare means the mixing the fertigation unit. That is separate.
Yeah, the fertigation unit which control the EC and pH.
Both EC and pH. Huh?
Yeah.
Okay, now we should go further. Thank you, Bharat sir, for giving a nice presentation as well as the interactive session to our students as well as the faculty members as well as all the participants. So on the behalf of all the participants and on the behalf of our university, I am again thanking you. Thank you very much, Bharat Swami sir.
Okay, thank you, sir.
Thank you, sir. Okay. Chirag, sorry, Karkar Jignesh.
Yes, I am online.
Okay. Our next speaker is Engineer Jignesh Karkar. He is a manager of technical services, NAHEP Irrigation, Vadodara, and he is going to deliver a lecture on the automatic drip irrigation controllers. Let me introduce Karkar Jignesh and his work profile. About his work profile, Karkar Jignesh has done his BTech Agriculture Engineering in the year of 2003 from the College of Agricultural Engineering and Technology, Junagadh Agricultural University, Junagadh. After that, he has completed his MTech from the same university. Then after, since 2006, he is associated with the NAHEP Irrigation India Private Limited for the as a various designations. He has started his career from a junior sales engineer as a sales executive, and now he is a manager. He is a territory manager. He is looking after design functions, ASTS functions, marketing activity of entire Western India, material forecasting, technical training to employees as well as the channel partners, CRM, that is a toll-free number related queries, product and quality management, digital farming solution, community irrigation, logistic planning and support, and tendering process of the company. So he has very much responsibility of, from the company. So I am welcoming Engineer Jignesh Karkar.
Jignesh, over to you. Now you can share your screen.
Yes, yes. I'm not able to share my screen. Can you help me?
So we make you host.
Yeah, yeah.
Make you host. On the center of the screen, there is a green symbol. Share screen.
No, when I click on share screen, there is a two option. One participant can share at a time and multiple participant can share simultaneously.
मल्टीपल वालों सिलेक्ट करो ना करना पे.
It is already selected, but I am not able to share my files.
Let me check. भाई जितने में कौन से? आप म्यूट करो.
Can my screen is visible now?
Yes, sir.
Yes, sir.
Okay.
Okay, thank you, thank you. Thank you. Share screen નથી થતી હવે.
So I am audible properly?
Yes, sir.
Yes, sir.
So good afternoon. Mr. Talavia introduced me, so I am not taking much time on it. Today our topic is to know about different types of controller. What is its working principle? And what is a fixed controller and what is a expandable controller? All controllers inputs and output limitation, their working limitation, then its configuration, then different models, introduction, programming and features. So now we know about the principle of automation. So there is a three type of controller available in irrigation market. First is a time based, second is a volume based, and third is a real time sensor based. So in first case, only we control controller by start given start time and end time. So in this case, we also repeat number of cycles per day, maximum duration, minimum duration, like that. Second is a volume based controller. So volume based controller typically come with the time based features. In a volume based controller, we will give a quantity of water in liters or meter cube, and we also set a number of cycle and maximum number of cycle depend on the model and manufacturer of the controller. And we also add sequential autometering valves, which is called semi-automatic in a volume-based controller. And third is a real-time sensor-based controller, in which we also introduce sensor like tensiometer, solar radiation, vapor pressure deficit, evapotranspiration, moisture, like that. So now quickly go by advantage and disadvantage of different types of system. So here we discuss about time-based system. So what it advantage? It first of all, it is cheapest system because there is no any advanced specification. It is easy to operate. We need to give only start time and end time, and this start and end time again bifurcated in seconds, minutes, or hours. Its disadvantage is there is no any feedback system, so we are not able to monitoring. And there is also controller available in market having a no memory. So once your light gets off, your total program get erased. So you need to configure again. Same way, volume-based system, it advantages we have a operational flexibility like time and volume, and we have a exact monitoring of quality and flow calculation, and it help us if there is a no flow, low flow, or high flow. So here, if you put a controller and generally start the borewell motor, and if you cannot put a volume-based system, in this case, if there is any problem in pump, like pump burn out and there is no flow from pump, or there is some issue which gives low flow, or if field valve not open on time and high flow is there. So this type of deviation in flow we can easily measure with a volume controller. First disadvantage is it is a costly in comparison with time based, because we need to add a water meter and different types of flow meter in this system. Third is a sensor based system. It advantages irrigation is executed as and when required. So if we are having a issue of water, electricity, then it give us on-off operation based on combination of time, volume, and sensor based. It's again costly than volume based system, because in addition to volume based component, we need to add sensor in this system. So, and again, this system means number of sensor depend upon the size or geographical condition. It means your farm size. There is also some challenges to maintain the sensor, and if any sensor fails, then it give different readings, and maybe some operation delayed, or watering may be increased versus sensor failure. Setting are critical things, so it is not easy, and it is not small farmer affordable system. Now, if we see how any control operation, so in any control there is an input, and based on this input, controller gives us output. So in any controller, if we give a temperature, humidity, wind speed, wind direction, sun radiation, CO2, pH, EC, rain, water quality, etc. Parameter with the help of sensor, or either put a manual value. It operates our valves, field valves. It on our field valves. It also on fertilizer pump, water pump. It also flush our filters. And in case of greenhouse, we also able to operate windows, fans, screens, motor, foggers, heaters, CO2 sprayers, and humidifiers. So if we talk about our product basket, we have 4 to 5 types of controller. First is a NMC Swastik. NMC means NAHEP mid-range controller. Swastik is our first controller having a limited output, and we generally used for a big flush of filter. Second is a Nano, which is our entry-level controller. Third is a NMC Junior, a complete nutrition controller with a climate controller also. Fourth is a NMC Pro. It is a again controller come with the nutrition and climate control system. Basically, it is a expandable controller, and we expand this controller up to 256 output. So now we just deep dive in individual controller. Swastika, basically we use this controller to flush the gravel and hydrocyclone filter. This controller work on both the level of electricity, single or 3-phase, and this is a only time-based controller. Now we move to Nano. It is a compact controller having a fixed output. Sorry. So this controller having a different types of controller function to operate 4, 8 like valves and 5 dedicated inputs. There is no sensor and no PC connectivity available in this controller, but you upgrade the software version in this controller. There is also password protection for this utility function, data plug for backup and setting and configuration, and free PC software for remote programming and data logging. This controller, 50 controllers we can keep in one network, and it is a communicate component for this, or putting 50 controllers into line, we need a separate NMC controllers. This is a look of Nano controller. Here there is a regulator type of switch. Here the different types of settings and automation component which you need to control. So as we discussed, this is a real-time clock available with irrigation, 8 irrigation valves, pre-configured output for a pump or master valve, 1 number. Filter we can flush 2 numbers, fertilizer channel up to 1 number, alarm 1 number. Irrigation of 4 valve we can control simultaneously. 5 water and fertilizer meters we also measure simultaneously, and it will work time and volume based. And we will also control based on time and external condition like water meter. And we have an irrigation event up to 128. We can use this controller in greenhouses, open field or orchard field. This is a small hydraulic setup. This is our water source. This is our pump, filtration station, water meter, venturi, and field valve. Now we move to junior. This is a again our fixed controller having a 15 output. So basic irrigation, we use this controller for irrigation as well as fertigation controller. So this is a setup for basic irrigation control. So this is water source, this is main line, water meter, and field valve. So if we need to control our irrigation based on time and quantity, then this is its line diagram. Now, in addition to irrigation, if we need to give fertigation to our crop, then water source, main pump, filter remains same. Water meter also remains same. We need to add any dosing machine like fertigate or netajet into the system, which will give us quantitative fertigation like spread or bulk and proportionate dosing with AC and pH control. We can also add various interactive function in the junior. If we use this junior controller in greenhouses, then in greenhouses we also need to control the temperature and humidity. And this temperature, to control the temperature and increase the humidity, we specially put foggers. So this foggers runs 5 or 7 or 10 seconds for every 5 minutes or 10 minutes cycle. So it is difficult to operate the sensor based on manual operation. So we put a sensor, temperature and humidity, and set the temperature and humidity value in the controller. So based on trigger received from the sensor, it will command to the booster pump, and booster pump flows the water, and solenoid valve will open for 5 to 10 or 12 seconds depending upon requirement of our operation, and they immediately cool down the temperature. Now if we look at the main features, then in case of Nano, we operate only one water pump. Here we having a multiple pump control. Filter flushing also available on pressure sustaining valve. So if here we filter flushing any filter with two type of system. One is a based on inlet and outlet pressure difference, and second is a based on time frame. So if we added here pressure sustaining type of valve, and we set the pressure difference from inlet and outlet, then we when our value reaches on a sensor, it will automatically flush the sensor. And simultaneously, if we are having a lower frequency of a filter clogging, then in case of this scenario, we only put interval that every 3 hours, every 6 or every 8 hours filter get flushed. So this type of two scenario we will use in this controller. As I said, it is available with 50 outputs. EC and pH monitoring and control is there. Multiple fertilizer mixing programming is there. Multiple water fertilizer auxiliary flow meter we also add in this. And for all our operation data also get recorded in this controller. So if we look at the software specification, irrigation program up to 15, number of start time per program 6, number of cycle per start time 99. So this is much detail for software specification side. Here hardware specifications, all our controller running on a single phase, having a 6 digital and 5 analog inputs. It is available with surge protection. Now we move to NMC Pro controller. So NMC Pro is a flexible controller, expandable controller. So in this case, we increase its input, outputs, and sensor connection based on our requirement. It is also operated multiple pump, and number of water meters up to 6 number we will able to join in this controller. Pre-EC control for water mixing junction. So what is it? It is a specially features required for soil-less greenhouses in which we can irrigate or fertigate our crop. And in this, we also collect drain water having a fertilizer, and we mix the drain water plus fresh water to know the specific level of AC and pH. So this type of pre-EC and pH control also we maintain with the Pro controller. And all the controller having a software updated facility. So is there any new features available? And we have a data plug type of facility in which we load the software and upload to the CPU card. And we have also additional data plug like a pen drive. So we also get all control settings into data plug. So in case of any failure, and if we need to configure again, then we do not need to configure line by line. We just copy paste from the pen drive, and we will get all the configuration from the same controller. This is a controller look. Now, as you see, this is a screen, this is keyboard. This is power supply. This is output card. Here you saw vacant space. So this is for inserting of this type of card. So as I said, it is expandable controller. So it is basically available for with 16 outputs, and one box we can expand up to 64 outputs. So here we can add this type of cards having an output, either maybe digital or either maybe analog. This is a display and keyboard circuits. So as we discussed, it is having a 256 output, and digital output we can increase up to 32. Analog output we can increase up to 22. And here we have also separate communication port, which is RS-232 and RS-485 for connection to the computer. And these controllers can work for irrigation, pump control, flow alarms, filter flushing, give the nutrition, irrigation trigger, drainage management, alarm reporting, logbooks, ECM and pH pre-control, cooling and humidification, misting and water heating. Now, let's look at different types of arrangement for the NMC Pro control. So as you aware, this is a basic controller having a water meter, main pump and field valves. This is a second type of arrangement. So if we have two different main line, then two different main line we will run at a time, and we can allot different types of valve to different types of pump. We can also control 24 filter based on DP, means pressure difference switches, and we also control the low pressure with this help of this system. Now, if we need to add nutrition in this system, then as per earlier case, we need to add any dosing machine. All the dosing machine details we will clear in upcoming sessions. As we discussed, we also add treated water in the system, and this is the diagram of this system. So we also put a float control to start and stop the filling of the tank up to 8 tanks. This is a ECN pH pre-control. This is a raw water. This is a treated water. We need to put some type of metering valve in this, and this will control by this controller. And we also, if we also need to mix the different water source to the single line, then we also do the operation with the help of this controller. And if we have a water recycling system, then in this case, this controller also help us. Now, as we discuss, this controller extend up to 256 outputs. And as we seen earlier, this controller has only 64 output. So if we need to increase from 64 to 256, then we need to add 64 outlet expansion box. So in this 1 to 64 for a host controller, and then another 65 to 128 for expansion box 1, then 129 to 192 expansion box number 2, and 193 to 256 for expansion box 3. And we can control or laying this controller having a limitation of 1.5 kilometer. We have also one solution called single net. In this, we also extend output from 2 to 256 by using a single net. In a single net, we have only single wire which connect all type of this single net unit, and this type of single net unit again connected to the water meter or fill valves. So like that, here we need to add single net host, and this is single net RTU. So if we required wireless operation, then we also add single net RTU in this case, and in this case we increase our cable length up to 10 kilometers. Again, if we have a more than 10 kilometer range, then we use this controller with our radio net controller. In this controller connect with the radio net host having an antenna, and in field we use RTU, which is called radio terminal unit. Each RTU placed at each valve junction, and all RTU working with the solar panel and battery, and it gives a receive command from the controller and accordingly on of the valves. And if we attach the water meter to the RTU, then it also sends the water meter reading and send to the controller. Now this is a comparison for NMC Pro and Junior. So for Junior, we use small and mid-range type of farms, and in a Pro, as usual, we can use for a large number of farmers. Here we can use 256 outlet. Here we have a limitation for 15 outlet. Here we plan irrigation by time, both the condition, and here we having also sensor based operation. Filter flushing 24 numbers, here 14 numbers. Nutrition up to 8 dosing channel. Both here nutrition is same in both the controller. Here we control 2 ECN pH, means by using Pro controller we can manage pre-ECN control, while we in case of Junior we are not able to maintain pre-ECN pH control. ECN pH control is there, drainage management is there, and flow management water meter is there. Pump, here we add 6 pumps Cooling, here we add 8 temperature plus 8 relative humidity sensor. Here 2 temperature and 1 relative humidity sensor. Alarm is there, logbook is there, NPC communication is there. So there is some functional limitation in a junior versus pro. Okay, so till this time we saw our old controller, which we called legacy controller. In this old controller, we need a human intervention. So either you can use time-based controller, volume-based controller, or sensor-based controller. There is a limitation to see the inputs data and use our brain. And accordingly, with the help of our brain, we need to again feed or input data into the controller, and accordingly controller works. So now this time we introduce first time in industries iode-based irrigation system, which is having a brain. So there is no need to human brain. It will monitor, analyze, and control the system. So let's look the system overview. We call this system a NAHEP-IDP system. So let's look its video. So as we discussed, in our existing system, we are having a portfolio of sensing and monitoring. So we have different sensor for ECPH, soil moisture sensor, humidity, climate sensor, and we have different types of controller based on sensing the data and based on human interface. Our controller controls the irrigation and fertigation operation, and we have additional software to analysis the sensor data or inputs data, and accordingly we give output to the controller. So this analysis and decision support put into the NAHEP-IDP system, and as you are aware, we born in 1965. So till now we having a 56 years of experience for irrigation and fertigation. So we put algorithm into our system based on a different crop, based on different soil type and climatic condition. So it will help to analysis based on external condition and working our operation. So in upcoming slides, we get more detail about it. This is the interface. You can control this controller with the help of controller screen, with the help of desktop, laptop, or mobile phone or tablets. It is a simple irrigation interfaces, a map overview. So we have a separate session on NAHEP-IDP working and setup also. So each and every aspect in detail we will cover during this session. Now let's quickly look at components of the NAHEP system. So this is a MCU. MCU means main control unit. It is a heart of automation system. It basically put on our water source. We connected this MCU to the fertigation system. Then we having a two models. First is a wireless and second is a with wire. So here we talk wireless system. So this MCU creates the wavelength which receive from the RTU. So MCU pass the message to the RTU, and accordingly RTU get the data from the sensor, and accordingly it on and off the solenoid valves. RTU means remote terminal unit. All this MCU controlled by a cloud data, and through the internet we can see from our mobile and desktop what is the exact condition live in our field. So there is a different type of NAHEP system components, which is net MCU, net RTU, cloud, dynamic crop model, sensor, dosing systems, which let's discuss in detail. So this is a net MCU. This is a fit for all farm size, and having a complex, if we having a complex arrangement like different type, we having a different number of water sources, different cropping pattern like various crop. So in this case, we have a different irrigation and fertigation schedule for a different crop. So this type of complex arrangement also can handle by net MCU. This is a multiple mainline controller. So number of pumps you can operate parallelly, simultaneously with the help of this controller. And this is a military grade hardware connected via Wi-Fi, Bluetooth, cellular. This controller, our old NetBit controller, developed by company name Emprest, which is a Israeli company working in Israel defense system, which also developed Iron Dome technology. So this company developed all NetAFM controller. And the beauty of this controller is once you purchase it, there is no need to change its hardware. You need all software updates as per our iPhone and Android system to the controller, and accordingly your function will modify or add. Now this is a RTU. It is a remote terminal unit, transmit the field data and activity from the different components. So RTU consists input for the sensor and output to operate the valve, pump, or dosing machine. The beauty of this unit is it is equipped to control the operation up to 10 kilometer range. Means one place we put a MCU and there is a aerial distance is 10 kilometer and having a no vegetation or no electrical disturbance, then it range up to 10 kilometer. And it is available with the solar and battery also. It is also military grade hardware. Now let's look about the cloud software. So here, as I told you earlier, we have 56 years of experience in irrigation and different hydraulic conditions. So we prepare a cloud software. We called it dynamic crop model. In dynamic crop model, we having a two types of system. First is a irrigation model, and second is a crop model or fertigation model. So in this we put our algorithm, and based on our algorithm and external data like weather and satellite, it calculates the upcoming operation So I give you an example. If I plan my irrigation for 50 minutes, at that time I don't know whether rain is come or whether temperature increase or not. So if I put a weather station or a temperature and sensor data to the in my field, at that time if I put plan 50-minute irrigation operation and suddenly rain comes or suddenly temperature increase, then all this external data monitored by the MCU, it will compete with the our pre-program, and then it advises to increase or decrease our irrigation and fertigation operation based on the external data condition. Likewise, it is an open platform. So nowadays, if there is any R&D institute or there is a different type of industry which require the inputs data from the farm to control their another operation, then it is also possible in this case. And all data backup and updates you receive online. Different types of reports you also get from the NetBit. Now let's discuss about the crop model. So here we also put one algorithm based on a different crop growing stage and accordingly climatic data and farmer input. So I give you an example. If I grow up pomo crop, then I need to select its variety and sowing date. And based on my inputs, it automatically calculates its various development stages, and it gives irrigation and fertigation recommendation based on crop life cycle and data, existing climatical data. And if I run this system second year, then it also computing the data which I used in last year, then current weather condition, and third is my current input data. So this having a facility to compounding past data also. Now let's look one video. Let's show the working of NetBit. Okay, and we also installed this NetBit system in Junagadh Agriculture University. Now let's look at NetBit 1. So as we discussed earlier, we having a various range of a controller. So NetBit system having a two controller. First is a NetMCU, which is a expandable and limitless facility controller. And for a small farmer, we also introduce another controller, which is from NetBit family, which is, we called it NetBit 1. So this is a NetBit 1 controller. Let's quick look for this controller also. By using of this controller, we can target at small and medium farmers and give them liberty to control their irrigation and fertigation remotely. One thing I forgot to mention here, all these controller work with internet and without internet. So while you inserting any controller on your farm, at the time, if you put internet SIM card on it, then you will able to handle controller anywhere from the world via cloud. And if there is a no availability of internet at your site, then you can control this controller with a Wi-Fi, having a Wi-Fi range of 100 to 200 meters. So this controller NetBit 1 is a manage both irrigation and fertigation up to 3 dosing channels. Efficiency, it is efficient energy consumption management, special during power cuts. So if you do, if having a electricity cut off, then it automatically set up the operation, and it having a backup battery. So when your electricity resume, it automatically on the irrigation pump, fertigation pump, and field walls, and complete your irrigation and fertigation operation. And same like NetBit MCU, it having also a calendar, map view, weather forecast, and it controls the pump, filter, dosing machine, and it also gives the reading of the water meter and send hydraulic alerts like no flow, high flow, etc. So now quick look at its hydraulic configuration. It operates only one pump and one valve. It having a 16 outputs, which is 5 to which control 5 to 10 acre. This is only available for AC valve. So we have wired option in this case. We have a no wireless operation for a NetBit 1. In a previous case, NetBit MCU, we have both option, wire and without wire. It also, NetBit 1 also handle the 2-3 dosing channels, and it also give fertilizer bulk or proportionate as we required. So plus the filters. And if we talk about its connectivity, then we can connect it with cellular via internet or smartphone. And it also having a IP65 outdoor installation. And there is a no screen on this unit. So we need to get connected this instrument via Wi-Fi to our any of instrument like smartphone, tablet, or a laptop. And once you configure it, once you set your irrigation and fertigation program, after that controller automatically behave as per our instruction. And when we need to modify or check its live scenario, in this case we required stable internet connection either from a LAN or SIM through SIM card. And in this case we also get live alerts from the same instrument. So I mean to say there is no need to purchase any extra hardware. Only we need to connect internet source which we have. Okay, so thanks. This is up to all the NetAFM controllers. Now let's look if we have any question. I am happy to answer your question. Yes, over to you, host.
Jignesh sir. Hello.
Yes.
There is a questions in chat box. Some questions are there from the participants.
Yes, yes.
Okay. We will take one by one. Any percentage?
So from which chat I need to start?
Okay. What type of valves being used? Solenoid operated or motorized? What are the maximum size of valves?
Okay. Here we used solenoid valves only, and the size is from 2 inch to 12 inch. So we also cover the valve component in our upcoming session while we conduct the session of designing of automation system.
Yes, sir. Next is when this type of amazing cutting edge technologies are available and being used across the world, why is our central and state government is not including the auto system in public farm schemes? 50,000 crores being allotted for 5 years for the mainly manual drip irrigation systems.
See, as we discussed, there is some literacy required to operate this type of system. Nowadays, government spending so much money. In a previous session, you heard about the Ramthal. Today I came by visiting this type of project. We having another 10,000 hectare, 13,000 hectare project having a drip plus automation in our company business pipeline. And Karnataka government having a 4 types of their division, like in our Gujarat Narmada water source department. Karnataka government already floated a tender around 18,000 hectare area covered through the automated drip irrigation system. So what they are doing, they are tendering 10,000 or more than 10,000 hectare area in which they construct separate from pump house on the canal end, and from that they build a primary filtration unit, and then secondary filtration unit, and then solenoid valve cluster, and then connection goes to the individual farmer field, and all these individual farmer will operate their irrigation based on the drip irrigation system, just like as corporation water comes to our home. So government nowadays also introduce this type of big project which covered with the help of automation and micro irrigation system. And Ramthal is Asia's biggest community irrigation project which cover 24,000 hectare of land, and it is now working since last 3 years. So it is not that government not spending money in automation.
Okay, sir. Engineer Chitra is asking what is the cost of the net bit?
See, net bit is a system in which we have a different sections like as controller, dosing machine, field valves, and sensor. So if here in our case, NAHEP case, we only change our controller. We have the same dosing machine, we have the same sensor, same solenoid valves. So if you having the option of net bit, then it will start from 90,000 to 5 lakh. So depend upon your farm size, depend upon your irrigation and fertigation requirement, cost is vary.
Yes. Pavitra is asking majorly in which crops automation is used other than floriculture.
Okay. There is no any limitation to use automation system in any crop, but high revenue crop in which you require EC and pH control, and also you having a control, precise control on your irrigation and fertigation requirement. I share you one example of a pomegranate. So any agriculture crop, either it is a horticulture or case crop, they having its tolerance value for a EC and pH. EC is a electrical conductivity, pH is a acid and alkaline concentration. So EC is basically salt, which is available in our irrigation water. So you over that, if we give flood irrigation to the soil, then the salt of this water add into the soil, and fertility of soil decreases. But in case of drip or automation, we need to give fertilizer to the plant or crop. So in this case, again we add salt or salt in form of fertilizer. So what automation do? Automation do or give fertilizer as per our plant, but it will check every few minutes EC level of water, and accordingly it on and off fertilizer injection into the system. So ultimately what we will get desired EC water, even we injecting the fertigation. So in this case, there is a tolerance value of a crop. So if I give example of pomegranate, if you having a 1.5 EC water, then pomegranate crop will give 100% of yield. And if your EC value increase up to 2, then pomegranate crop production decrease from 20 to 25%. So you can imagine. So this type of crop also give a maximum output if we using automation. But if we get if we can get example of wheat or cotton, in this case commodity price itself not support the BC ratio of this automation system. So answer to your question, apart from floriculture, we can use it for horticulture in greenhouses, and some vegetable crop also.
Okay, sir. Now we will finish our afternoon session here, and we will meet tomorrow at 9 o'clock. Our speaker is next. Our speaker is Rakesh Donga, founder of Donga Water Tech. He will take his session tomorrow 9 a.m. Thank you, sir. Jignesh sir. We will meet at 12 February. Your next session will be on 12 February.
Yes. Thank you. Thanks a lot.
Thank you. Okay, participants, we will meet tomorrow 9 a.m. Thank you.